by the world famous AutoCAD engine, but it has a whole load of mechanical stuff built on top to allow you to create your mechanical drawings with ease. So for example, the drawing you can see on the screen at the moment is a pump subassembly. And you can see there that we've got all the sections, the centers, the balloons, the parts list, and so on. These are all specific functions of AutoCAD Mechanical. They take a lot longer to create in regular AutoCAD. So AutoCAD Mechanical has all of these mechanical parts and functions that allow you to work quicker and more effectively in a mechanical drawing environment. Now, as I said, this particular course takes you through all the essentials you need to know about AutoCAD Mechanical. So let's get going and get you working through some AutoCAD mechanical drawings, examples and exercises so that you can start learning how to become an efficient AutoCAD mechanical user. Before embarking on this AutoCAD mechanical course, here's a few things that you should know. You should have a basic working knowledge of regular AutoCAD first. You can get this from the Learning AutoCAD course in the library and also the AutoCAD Essential Training course in the library. And it's good that you have that good working knowledge of AutoCAD commands and methodologies. You'll need those as you start working through this AutoCAD mechanical course. Also, based on the fact that it is an AutoCAD mechanical course, a good working knowledge of mechanical drafting is also very useful. It's something you really should know before you start on this course. Things like bills of materials, standards, and so on. It's good if you know that kind of stuff before you start this course as well. And this particular course is ideal for all intermediate and advanced AutoCAD users. So if you've been using AutoCAD for a long time and you haven't done the Learning AutoCAD course or the AutoCAD Essential Training course, but you have got a good grasp of AutoCAD already, this course is ideal for those types of users, the intermediate and advanced AutoCAD users as well. The exercise files for this particular course are all stored in the LinkedIn Learning Library. They're normally stored as a zip file. You can download the zip file and unzip the files into a known location. Put it into, let's say, your hard drive, a cloud drive, or perhaps a server drive for other people to use. I'll let you know what you need for each chapter and each video. So I'll let you know which particular file you should be using for which particular video in each chapter. Any drawings in this particular course will be in the AutoCAD DWG file format unless specified otherwise, and all files are saved back to the AutoCAD 2013 DWG file format. The reason for that is it allows us to allow users who are using older versions of AutoCAD to take this particular course. And ideally, download the exercise files before starting the course, and then when you're about to jump into a video, make sure that the exercise file is open in AutoCAD Mechanical before you start. That way you can hit the ground running, start the video, and start working with the exercise file at the same time. The AutoCAD Mechanical 2022 interface is subtly different to older versions of AutoCAD Mechanical. You'll notice we're in this dark mode environment now in newer versions of AutoCAD Mechanical, a like grey-y black kind of environment. You'll also notice on the ribbon that the icons on the ribbon in the tabs are also actually much cleaner and much more refined. The reason being is this then ties in for use on higher res monitors and 4K monitors and so on, so that they display nice and cleanly and are easily recognizable when you're working with AutoCAD Mechanical. The 2022 version of AutoCAD Mechanical also has a revamped Start tab as well, you'll notice. So you can see how things have changed in AutoCAD Mechanical 2022. Over here on the left, we have our open and our new. We've also got our recent files here, you'll notice. We can go to Autodesk Docs and also to the learning page on the Autodesk website. We've also got various links here, what's new, mobile app, web app, and so on. And over here on the Connect side of things, it lets me know that I'm logged in using my email address for my Autodesk account. You can also send feedback there if you want to. I'll just jump back into this particular drawing that we've got open in AutoCAD Mechanical 2022. Just be aware though that if you are using a slightly older version of AutoCAD Mechanical to follow along with this course, that the interface might look slightly different. The icons might look slightly different, and they might behave slightly differently as well, depending on which version of AutoCAD Mechanical you're using. As I mentioned previously, you're taking this particular AutoCAD Mechanical course. And when it comes to AutoCAD, there are some prerequisite courses that I can recommend to you. We've got the new AutoCAD course structure in the LinkedIn Learning Library at the moment, where you've got the Learning AutoCAD 2022 course, and then you've got further AutoCAD courses that dive deeper, such as AutoCAD 2022 Essential Training, AutoCAD 2022 Interface. There's also Spaces and Workspaces and the Output course as well. These are good AutoCAD prerequisite courses that you can take before you embark on your AutoCAD Mechanical course. The reason being is it teaches you all the terminology and methodology that you need to know about AutoCAD before you then start using all of the functionality available to you in AutoCAD Mechanical. Other AutoCAD courses that could be useful to build up your knowledge of the tool sets that come through with your AutoCAD subscription are things like AutoCAD Electrical Implementing PLCs, and AutoCAD Architecture Essential Training. These are all related to other AutoCAD toolsets, but are also useful courses that you can consider looking at in the LinkedIn Learning Library. We're starting a new chapter now in our AutoCAD Mechanical Essential Training course. And what we're going to look at is the AutoCAD Mechanical User Interface. Now bear in mind, for this chapter you do not need to download any drawings, any folders or anything like that at all. I'm just taking you through the interface and showing you where things are and the differences between this interface and the regular AutoCAD interface. So let's have a look at this interface just in brief first, and then we'll get into a bit more detail in some of the other videos in the chapter. So when we first look at AutoCAD Mechanical, the layout of everything is still the same as regular AutoCAD. So over here we've got our application menu. Top of the screen, top left, we've got our quick access toolbar. We've got the tabs on the ribbon, you'll notice, and we've got the ribbon at the top of the screen. Got the info bar on the right hand side where we can sign into our Autodesk account. And then as we come down into the drawing area, you'll see it doesn't look any different. And also you'll notice the big difference is over on the left hand side. We have a thing called the mechanical browser. Now what this allows us to do is it allows us to work with our mechanical assemblies. So you'll notice in this drawing it's a robot arm assembly. So you can see here, if I expand these out, we've got the parts list for the main robot assembly, the robot, the plastic tray, and also the gripper assembly as well. So there's all these different parts of the robot arm, and they can all be defined as different parts of an assembly. And then what happens is you pull them all together. It's a bit like, I suppose, using external references in AutoCAD, but you're kind of linking them all together in the one model in AutoCAD Mechanical. Now, the whole idea of this interface is that the interface is the same for each Autodesk product. The ribbon at the top of the screen, command line at the bottom of the screen, model and layout tabs bottom left, status bar down here, bottom right. So you can see how everything is familiar to you from your regular AutoCAD, but there are subtle differences with your AutoCAD Mechanical. The AutoCAD Mechanical ribbon is subtly different to the regular AutoCAD ribbon. Now I'm just going to jump across a few of the tabs on the ribbon that differ from regular AutoCAD, but most of this you'll be able to find out for yourself. So the Home tab on the ribbon in AutoCAD Mechanical, you'll notice that we've got some new tabs and panels available to us. In the Home tab, though, we've got the Construction panel and the Detail panel. They're different to your regular AutoCAD. In the Annotation, we've got some new tools here. We've got things like Part Reference, Parts List, Bill of Materials. In the Insert tab on the ribbon, you'll notice that it looks remarkably similar to your regular AutoCAD ribbon. There's a few differences though. We've got the library over here. We've got IGES and step icons. So there are some subtle differences. Annotating, very different to regular AutoCAD. You've got things like power dimension, multiple dimension. And over here, we've got lots of different dimensioning tools that you don't get in regular AutoCAD. You'll also notice you've got things like symbols, balloons, bill of materials, and sheets. Again, different to regular AutoCAD. The parametrics don't differ at all. They're pretty much the same as regular AutoCAD. This is the biggie though, the Content tab in AutoCAD Mechanical. So you'll notice we have content libraries, Content Manager, New Content. We've got fasteners, holes, shafts, parts, motors, tools, and even mechanical calculations. In the View tab, you'll notice that there are some slight differences there, but you'll notice you've got things like content libraries and the Mechanical Layer Manager. Over here, you'll notice the Mechanical Browser. If I click on it, the browser disappears from the left-hand side of the screen. Click on it again, switches it back on again. And when we start moving into Manage and Output, they don't change much at all. So you can see there that there are some subtle differences to the ribbon in AutoCAD Mechanical, but there's still a lot of the regular AutoCAD functionality there. Once again, we're looking at the differences between AutoCAD Mechanical and regular AutoCAD, and we're going to have a little look at the shortcut menu now. Now, this is normally located on your right click on your mouse, so move the crosshair into the center of the drawing. If you're using a drawing, obviously, I haven't asked you to download anything. And I'm going to right click now, and you'll notice that in AutoCAD Mechanical, there are some subtle differences to the default right click menu. We've got things like power dimension, power recall, and these allow you to work quickly and easily in AutoCAD Mechanical by allowing you to basically work in a way that is related to the AutoCAD Mechanical interface rather than the regular AutoCAD interface. I'll hit escape there now, and I'm going to zoom in just on one of the elements of this robot arm. So I'm going to highlight something like, let's say, this particular center line here. I'll click on it, right click, and you'll notice that now it looks remarkably similar to the regular context sensitive AutoCAD shortcut menu. But you've still got things like your power recall is in there, but everything else is pretty much the same: edit, erase, move, and so on. Now, it does depend on what you click on and what you select and what you're working on at any given time. But what you will find is that shortcut menu is slightly enhanced. It's a little bit different to your regular AutoCAD shortcut menu. So just be aware of that when you're working in your AutoCAD Mechanical drawings. The Mechanical Browser is unique to AutoCAD Mechanical, and it's a very useful tool. It allows you to navigate all of the parts of the assemblies that you create in AutoCAD Mechanical. So it normally resides on the left-hand side of the screen over here. So you can see I've got everything open. I've got the main part of the robot assembly open. I've got the robot part of the robot assembly open, etc., etc. Now, if I go and select an element of the assembly like so, what will happen is that is now highlighted. And if I scroll down, you may find that it highlights here in the Mechanical Browser, but not always. The best way to do that is to select something in the Mechanical Browser first. That's the best way. If you do it this way, you'll see that things start to highlight. So the two clamps highlight when I highlight it there. Can you see? I've got it highlighted in the Mechanical Browser, and it highlights in the drawing when I move over it in the Mechanical Browser. If I come into the drawing area, hit escape a couple of times, can you see there? Only the objects highlighted in the Mechanical Browser highlight when I move over into the Mechanical Browser. Now, bear in mind, in the View tab on the ribbon, I can turn the Mechanical Browser off. It's this icon here. And you can see the text command there to type it in is AM Browser. So if I click there, turns it off. If I click there again, turns it on. It even remembers the fact that I've got the clamp selected in the browser. So if I went to something like a cylinder now, you'll see the cylinders highlight, levers highlight, joints highlight, gripper plate highlights, and so on. That's the whole idea of the mechanical browser. Now, if I start to minimize things here, you'll see it starts to actually now highlight the entire assembly. So there's the gripper assembly. So if I select the plastic tray now, there's the plastic tray at the bottom. If I select the robot, there's the robot there. If I select main and zoom out slightly, hover over it there, you'll see the main one doesn't actually highlight because that's the whole object. If I go to the parts list though, that does highlight. There it is there. Can you see it highlighting just top right there in the drawing itself? So let's double click on the wheel to zoom extents again, like so. That is the mechanical browser available to you in AutoCAD Mechanical only. One more quick thing though, don't forget as well, you can right click over these things. You can edit the parts list. You can open the parts list. I can right click over the plastic tray and I can select it in model space. I can zoom to it. I can delete it. I can make it visible or invisible, etc., etc. There's a whole raft of commands available off of the mechanical browser as well. So remember that right click too. That's very important in the mechanical browser as well. Drafting settings in AutoCAD Mechanical don't differ that much from your regular AutoCAD. They're located in the same place, the bottom right corner of the screen. So there's all your drafting settings in your status bar. So you can click on the flyout menus. For example, there's your polar tracking there. Click on the little flyout arrow again, closes it again. Same with object snaps, like so, and then click on the arrow again. Now you will find there's a few icons down on the drafting settings that you wouldn't normally get in regular AutoCAD. They're over here. So you've got mechanical structure on. You've also got structure selection order as well. Coming over this way, selection lock and also reference lock. These are tools that are available to you in AutoCAD Mechanical only. If you right click over any of them, you may find that you get settings, but you'll find normally that's not the case. As you can see, they're just on and off toggles. Right clicked on each one, nothing like sort of snap or grid or object snap where you might get something pop up. So for example here, if I click on object snap, I can go to object snap settings and that'll bring up my drafting settings dialog box, as you can see. Whereas the AutoCAD mechanical settings, I'll just click on cancel there, are literally just on off toggles. So as you can see, mechanical structure on, structure selection order, and so on and so forth. So it allows you to toggle various tools in AutoCAD mechanical on and off. Apart from that though, your drafting settings tend to behave in a very similar way to regular AutoCAD. The quick access toolbar in AutoCAD Mechanical is remarkably similar to your regular AutoCAD. It's located in the usual spot, top left corner of the screen. So we've got things like new, open, save, save as. You've also got the new functionality that came along with the 2019 versions, which is open from web and mobile and save to web and mobile. You've also got plot and the usual undo and redo. If I come to here though, you've got switch windows. Now this is quite a cool one to have on your quick access toolbar. The reason being is it allows you to switch between windows of different drawings you may have open at any given time in AutoCAD Mechanical. As usual, you can click on what I always jokingly call the eject button here, which looks like a DVD eject button. And you can add other commands if you want to. So all of these commands could be added. If I click on more commands, that'll open up what they call the CUI, the Customize User Interface dialog box, and you can go and pick whichever command you want to add to your quick access toolbar. I'm not going to add any, I'll click on cancel, but you can add as many as you like. One of the nice ones in newer versions of AutoCAD is the ability to add a layer. So if I click on layer here, you'll notice I can now control my layers from the quick access toolbar. It's up to you if you want to use that one. I'll just go back here and switch it back off again like so. Now, the trick is to utilize your quick access toolbar with all the settings that you use on a day-to-day basis. That way you're not scrabbling around on the ribbon trying to find things and work out where they are. Add the commands that you use on a regular basis to your quick access toolbar. That way they're always there as a go-to whenever you need them. We're starting a new chapter now, and we're going to be looking at object properties and layer management in your AutoCAD mechanical drawings. To that end, we've got a new drawing for you. It's called robot001.dwg, and make sure as well that you've got the gripper assembly new drawing in the same folder as your robot001 drawing. Let me show you what I mean. If I go to the insert tab here, go to the reference panel and click on this little arrow here, you want robot001 and gripper assembly new in the same folder, because the gripper assembly new drawing is a reference into the robot001 drawing. As long as they're both in the same folder, everything should work fine. So make sure they're both downloaded in the same folder. Now we're going to be looking at object properties and layer management in AutoCAD Mechanical. Now, AutoCAD Mechanical is quite unique because the layer management is managed by the property management, if you get my drift. If you bring in objects of specific properties, the layers are controlled by way of the object. So it kind of works in a way that you bring something into your AutoCAD Mechanical drawing and it's already on the right layer. Let me show you what I mean. If I go to the Home tab on the ribbon here, come into the Layers panel and click on this icon here, you'll see that we have an old-fashioned layer dialog box, very similar to the older AutoCAD Layer Properties Manager. It's not on a palette, it's in a dialog box. And this is the Mechanical Layer Manager. And if I go to this arrow here and click, I've got a new layer and a new layer definition as well. I can define layers for particular objects. And you'll notice that all of the AutoCAD Mechanical layers are AM. And you can see that they are used for associated objects here. Now, all of this is set up in your settings in your AutoCAD Mechanica, in your options. So if I just scroll down, there's all your regular layers. And if I expand the layer names, there's the gripper assembly new layers from the reference file. So you can see all of the controls are very, very similar. But it's all to do with what they call property management. So certain objects of certain properties will give you a certain layer. So if you know that you want to draw something in particular, like a section line or a plane line, you would use this layer here, AM10. If you want to do something different, let's say a contour, Contour 2 is on layer AM1. And the whole idea of this is it allows you to control these layers by way of the objects themselves. So you can create objects, and this is all based around this particular tab here, the Content tab. And you can see here that you've got content libraries and screw connections and holes. Bring in any of these elements and they all go onto the appropriate AutoCAD Mechanical layers. And that's what I mean when I'm talking about property management in AutoCAD Mechanical as we go through the course. So we're staying in our robot001.dwg file. I'm going to zoom in on the top view here of the robot assembly. And you can see that we've got various objects available to us there. So we've got, for example, here, standard parts such as a hexagon socket head cap screw. Now, if I select that particular object like that and go back to the Home tab on the ribbon, you'll see that that is on the layer AM0N. And that particular layer is for that particular object. So this is that automatic property management that I mentioned. All of these objects come into the drawing as blocks and they're already on the layers that they need to be on. So if I went to content, for example, and I came in here and said that I wanted a screw or a bolt from the content library. So I click there like so. What will happen is it'll actually allow me to bring something in, like a countersink head type or a hex head type. So if I select that there like so, what I can do is I can go and pick this from the graphical menu, or I can expand it out here. Now it takes a little while to load up, but there's all different head types. So let's go for the hex head type here. If I expand that, I can come in with any type of bolt here. There's flanged ones and heavy hex structural bolts and so on. I'm just going to go for a heavy hex structural bolt like that, and I want the front view like so. And then it'll ask for an insertion point. So I'm going to pick a point, say here, that midpoint there. Now it wouldn't actually go there perhaps. And then I'm going to specify the rotation angle coming vertically down like so, and then I can specify the size of it. So I'll go, let's say 1.5 inches there, and I'll click on finish like so. And there it is there. It's very large, as you can see. It's quite big, and I've deliberately chosen a big one like that. So that will come in like so, and it's inserted in. And now, as you can see, I get the option to hide the situation. We'll cover that later. I'm just going to OK that for the moment. So I OK that, and there it is there. Now I can either hide that situation or not hide it, depending on whether it's hidden detail or not. But if I select that bolt now and go back to my home tab, can you see there? It's AM0N again, same as these other bolts were over here. Now I'm going to delete that now, so I can right click and I want to erase it like so, and it goes. But that's the automatic property management, and it allows you to not have to worry so much about which layers your objects are on. The properties are already defined by the objects in the content libraries. We're staying in robot001.dwg, and we're going to have a little look now at layer control and controlling the layer display. So basically, I've got the drawing open, and we talked about property management in the previous couple of videos. I'm now going to go to the layer panel in the home tab on the ribbon, and once again click on this mechanical layer manager. Now, controlling the layers and the layer display is actually very, very easy. But what I'm going to do is expand a few of these columns here like so. So you've got replicated in layer group. You've got associated objects for all of your AutoCAD mechanical layers. If I come down the list, these are just regular layers here, as you can see. They look regular. They've got regular layer names. You can freeze them, you can lock them, you can add colors, you've got a line type and also a line weight as well. So you can see how easy it is to control these layers, but one of the benefits you have is that the objects assume they're AutoCAD mechanical layers like so. Now, I'm just going to bring the mechanical layer manager over here sort of idea. I'm going to take it slightly off the screen, but don't worry about that too much. And we talked about those bolts going in on the layer AMON, like so. Now, the control is very, very easy. You can freeze a layer. So if I do that, that will freeze that layer like so. But you'll notice it doesn't freeze it until I click on OK, like that. And then you'll notice that that doesn't actually make it disappear. Can you see? It kind of makes it detailed, almost like in a hidden detail kind of idea. And then if I go back to the mechanical layers again and go back to that 0N here and thaw it out, watch what happens. If I thaw that and click on OK, can you see it comes back to like its full glory again, if you see what I mean? So what you'll find is with some of these layers and with the layer control and the visibility, it doesn't actually make them disappear. What it does is it kind of either fades them or reduces their density and volume in the drawing. It's quite a clever tool because it means that you don't lose where those objects are. You can still see them, but they're kind of reduced in visibility. So if I selected, let's say, one of these center lines here like so, that's on layer 7, which is a regular layer. So if I went back to the mechanical layer manager now, and let's just bring this over here a bit and went down to say layer 7, going to scroll down. There's layer 7 there, for example. So if I now freeze that layer and click on OK, you'll see that those center lines literally just disappear. Whereas if you freeze some of the other AutoCAD mechanical objects, their layers don't fully disappear. So it's quite a clever tool, but I'll just undo that and bring those center lines back. So that's how you control the visibility and the layers. It's very, very similar to the controls that you have in the regular layer properties manager, but you've got a lot of AutoCAD mechanical functionality in there. Let's just go back one more time to the mechanical layer manager, and you'll also notice you've got lots of tools up here as well. So you can highlight objects, you can move into objects, you can also check layers, you can set as the current layer. It's kind of self-explanatory, that one. You can also delete layers. And if I expand here, I've got a new layer or a new layer definition. So the definition coming across here is this here, the associated objects, the definition. So I'll click on cancel now. And as you can see, the layer control and the layer properties and the layer visibility as well is really important in AutoCAD Mechanical. We're staying in our drawing Robot 001, and what I want to talk about now is drawing geometry on layers. Now, this is what you normally do in AutoCAD, but there's a different workflow and process in AutoCAD Mechanical. So go to the Home tab on your ribbon, and in your Layers panel, you can click on this flyout here, like so. And what this allows you to do is pick appropriate AutoCAD Mechanical objects, and it will decide on what layer the geometry is going to go on. So if I select Centerline, for example, it now puts me onto layer AM_7. Let's just jump into the layer manager a moment and have a look. AM7 is now the current drafting layer because I clicked on it in that drop down menu. And as you can see there, it's a cyan. It's a particular line type and it's 0.25mm line weight. If I scan across a little bit, it's used for center lines. So that's what happens when you utilize that drop down. It allows you to draw the object on the appropriate layer. The geometry gets drawn on the appropriate layer because you've specified that. So you don't have to worry about what layer it's on. It makes that layer current for you. So I'll click on OK now. I'll zoom in on, say, the base of the robot here. And let's say I want to draw a center line. I'll just draw a line for now. And I'll pick, let's say, a midpoint snap there. Take the line up to there, let's say, and click. Enter to finish. And if I zoom in on that now, it's a center line on the right layer, ready to go. So that's what I mean by geometry on the appropriate layer. And that's what I mean by property management in AutoCAD Mechanical. You pick the appropriate object and it goes on the appropriate AutoCAD Mechanical layer. We're starting another chapter now in our AutoCAD Mechanical course, and we're going to start looking at organizing our mechanical drawings. And we've got the drawing robot001.dwg available again. Download it from the library along with the Gripper Assembly New reference file. Make sure they're both in the same folder, and you should be fine when you download both of those files and put them in the same folder because the reference file path is relative. So as long as they're both in the same folder, we should be fine. Now we're going to look at creating our model, our drawing in AutoCAD Mechanical using what they call creation workflows. Now this is where the mechanical browser comes in, so just make sure you've got it switched on. If you haven't, go to the View tab, and it's this one here, Mechanical Browser Off, Mechanical Browser On. Now I've expanded everything out in the mechanical browser at the moment. You can see there's the Robot 001. That's our main drawing. That's the name of our drawing with our little red A next to it. Now if I start expanding all of these views out, can you see that we're building everything up with different views? So for example, if I went to Robot here, it highlights all of the robot both in the side view or front view and the top view. However, if I selected just top, can you see there's the top view? If I hover over it there in the mechanical browser, it highlights the top view. If I right click over it and select in model space, it's now selected in model space as well. So this is where you can see this workflow creation kicks in. And the whole idea of these workflows is you build things up as you go. So if I wanted to add something new to Robot 1, for example, if I just hit escape there to deselect everything, I can right click and I can come in here and I've got new component view, new annotation view. So if I went to new component, for example, it now asks me for a new component name, component 1. So what I'm going to do is I'm going to call it rectangle, like so. So I select rectangle and then it says enter new view name, top, front, side. So let's say front, for example. And then what I would do there is specify the parent view. Would that be the parent view, top, front, etc. And I'd specify that view as well. Do you see what's beginning to happen here? If I hit escape now, this is what's happening here. So we've got robot, top and front. So we've got a parent and a child arrangement. So the idea being is these workflows allow you to generate everything in groups. as you start designing in AutoCAD Mechanical. We're staying in our robot001.dwg file, and you can see I'm at the basement part of the robot in the AutoCAD Mechanical drawing here, the front view. Now, you've got to be very careful how you structure your drawing in AutoCAD Mechanical. Now, let's have a look at the mechanical browser on the left-hand side. If I go and select Basement 1, you can see it highlights quite happily like so. And basically, if I select robot, then can you see it selects that top part there as well? So if I hover over it in the mechanical browser, it shows the whole thing. So there's the robot, there's the basement, there's the axis. Can you see it's highlighting different objects? There's the plastic tray. Now the plastic tray is up here somewhere. There we go. There's the plastic tray there. Now I'm just going to double click on the wheel and zoom extents for a moment. And I want you to make sure that you're aware of this structure. It's really, really important, because if you look at each element of the AutoCAD Mechanical drawing, the main robot is up here, like so. That's the whole drawing. And then as you come down, each one of these elements, or basically parts, forms part of the Robot 001 assembly. And it's really important that you just basically work your way through the list. It doesn't matter which order the list goes in per se, because obviously each part forms part of that complete assembly. So if I selected the plastic tray, there it is there. And if I select it, it highlights both views, both the front and the top. But then I can break it down into front. So there's the front view, there's the top view. And the nice thing about it is once you've got all these elements selected for each of these particular parts of your structure, I can right click on plastic tray top and I can select it in the model space and it's selected straight away. I don't have to worry about actually going in and selecting all the individual lines, arcs, circles, etc. that make up that particular part of the assembly, because I've already set all of that up in my structure in the mechanical browser. I'll just hit escape there to deselect that. That's the benefit of this structure within the mechanical browser. It allows you to actually have, in essence, a shopping list of objects in your AutoCAD Mechanical drawings. We're staying in our robot001.dwg file, and we're going to have a look now at creating a mechanical drawing using structure. Now, we're going to imagine that we're still developing our robot here that we've got in our AutoCAD Mechanical drawing. Now, I'm not going to create an entire mechanical drawing from scratch. That would take hours. But what I'm going to do is I'm going to add a small element called a shield, and that's going to form part of our drawing structure. So I'm going to zoom in on the basement part of the front view here. So I'm going to get in nice and tight, like so. And I'm going to make sure I'm on the AM0 layer there in the layers panel in the home tab on the ribbon. And all I'm going to draw is a very simple little rectangle to represent a shield at the back of the basement where the robot rotates. So I'm going to go to the rectangle command in the draw panel and just literally select regular rectangle, that one there. So rectangle corner to corner. You'll notice in the drop down, there's lots of different rectangles in AutoCAD Mechanical. So I'm going to go for this one here. And I'm just going to pick a point, drag it upwards like so. And then I'm just going to hover and use my object snap tracking just to get the thickness there. And just take it up to say there. Now, I'm doing this very randomly, I hasten to add. You'd obviously draw this a lot more accurately. But that is now a new rectangle in the drawing. So I go over to the mechanical browser, right click on Robot 001 and go New Component. So that's going to be a new component of this assembly for the Robot 001. So I select component like so. And it says enter new component name. And obviously you get a default of comp1. Now I'm going to call it shield. And it might be the shield at the back. So make sure you spell it right. I before E, except after C. There's shield there, and press enter to confirm. Now, you have a new view name. Now, the default is top. Now, this isn't top, this is front. So you make sure that you type front in rather than accept the top one. And you select the object for the new component view, which is going to be there, like so. And then you press enter to confirm, like so, and then you specify a base point. Now, this is important because you might want to reuse this structured data later on. So my base point is going to be that bottom left corner of the rectangle just there. Now, what you've got, if you look now at your mechanical browser, is a new component, Shield 1 Front View. Now, if I zoom out here, obviously you'd have a shield down here somewhere as well. As you can see, that bit sticks out there, and it's this bit here, where the shield is sitting on, just here, this rectangular bit here. So what you might do there now is create another rectangle down here. So let's do another rectangle, and I'll do it corner to corner again. So endpoint to endpoint, like so. So I've got my rectangle sitting on top there. And again, I'm going to go to Robot, right click, and I want new component. Or do I now? Do I need a new component, or do I need a new view? I can go down to Shield, and I can now go New Component View. Select the view name. So this will be top now, like so. Select the component like so. Click there and enter to finish. Base point, we'd probably go with something like an intersection there, like that. So now we've got a front and a top. Now, if I just do a quick double click on the wheel to zoom extents and just pan upwards a little bit so that we can see them, there's my front view there. There's my top view there. And what I've done is I've generated that structure as if I was generating a new AutoCAD mechanical drawing from scratch, but I've obviously only added 2 components. But that's how you build up all of those components to make that structure in your AutoCAD mechanical drawing. One of the major benefits of having all of this structured data in your mechanical browser in AutoCAD Mechanical is the fact that the data can be reused. The components can be reused from the structure in the mechanical browser. Now, what I've done in the Robot 001 drawing is I've done a zoom extent and kind of zoomed out a little and moved everything over to the left-hand side to give me plenty of space over here in the drawing area. I'm going to go to the mechanical browser now, and I'm going to go to the basement component here. I'm going to right click on it. I'm going to go to insert, and I'm going to go to component view. Now I want the front view like so. And now it prompts me to specify the parent view. Now the parent view is the top view in this case for basement 1 because it's nearest to basement 1. So can you see it says top there in the brackets on the command line? I'll just press enter to accept that. And now I've got a front view of the basement part of the robot. Now I can pick a point anywhere where I want this to go. I'm just going to zoom in and hover over that point there and get my polar tracking to kick in like so. And I'll come to there. And I can now specify a rotation angle, whichever way I want it to go. Press enter for 0 there, so it stays at the same angle. But can you see how I've recreated that now? And now I've got a front 2 there, like so. So I can recreate this. And one of the major benefits of this is if you've got loads of recurring components over and over again, say girders in a structural drawing, or let's say nuts and bolts in some steel work that might form a part of an assembly, you don't want to have to draw them over and over again. So what you do is you reuse them from your structure in the mechanical browser. And as you can see, that is front 2 now because it's the second front view in that basement component. And if I select it now, can you see it selects all 3? And there's top, and there's front, and there's front 2. So the benefit I've got now is I've got 3 different views of that basement 1. And it works really well. It allows you to reuse things really quickly and really productively. So reuse that structure data as much as you can when you're creating the geometry in your AutoCAD mechanical drawings. Once again, we're staying in our robot 001.dwg file, and what we're going to look at now is editing our structure data, which is actually very easy to do as well because you've got the mechanical browser in which to do it. Now, we've got the basement 1 there, for example. Now, what I can do is I can select something like front 2. If I right click on that and go to rename on the shortcut menu, I can rename the component or the view itself. Now, if I go to component, that's going to say to me, do I want to rename the component definition, which in this case obviously is basement. Now, I might want to change that to something like rotating base or something like that. I'm not going to, but if I did and clicked on OK, it would change the name of it in the mechanical browser structure. If I right click on front 2 again and go to rename this time and rename view, it prompts me, do I want to rename the view, the front view? So it could, for example, be side view. If I do side there and click on OK, watch what happens. I've now got side and side 2. If I right click again, rename and rename the view, change it back to front, and make sure obviously you don't capitalize the R like I've just done. And it goes back to front again. It's that quick and easy to rename it in the browser itself. But what about editing? What happens if I want to remove a view from a component in the drawing itself? Now, obviously, in this particular chapter, we created the front 2 view in the basement 1 component. So if I now right click on the front 2 view, I can delete that particular view. If I click on delete now, you can see that that front view disappears and I'm back to top and front in basement 1. And you'll also see I've got shield here as well. Remember the shield we placed earlier? So if I select that particular component now instead of a view and right click, I can delete a component as well. Now it'll prompt me with components if I want to remove it. Now bear in mind, that's been deleted and no longer used in the drawing. Would I like to remove the definition as well? So if I select shield there like so and say yes, that particular one disappears. Now you'll notice that it's also disappeared down here. That's because I selected the component to be deleted and not obviously the view. So all of the views have gone because the component has gone this time as well. So that's how you can edit your structured data quickly and easily as well. So as quickly as you can recreate it and reuse it, you can obviously edit it and delete it where necessary as well. We're starting a new chapter now in AutoCAD Mechanical Course, and we're going to be looking at the key geometry that you work on in your AutoCAD Mechanical drawings and also the core design tools that we use. So we've got a new drawing in the library for you. It's called cylinder_part.dwg. You can see it there at the top of the screen. And download that from the library to obviously follow along with this video. And basically it's a cylindrical part. You can see some section markers here, AA. There's a side view there. And if I just pan up slightly, there's the AA annotation waiting for obviously a section view to go in here. Now the first thing we're going to do is we're going to place a rectangle around all this hidden detailing here. So I'm going to zoom in nice and tight on that first, and you can see that all this magenta dashed lines here are the hidden detail. The circle is there as a point of reference. Now what's really nice is you've got a whole load of core design tools in AutoCAD Mechanical that are very different to your regular AutoCAD ones. So if I go to the rectangle command, you'll see I've not just got the regular corner to corner rectangle here. I've got all different ones, midpoint of height, midpoint of base, center. I can draw squares in the same way. I'm going to select this one here, which is rectangle, midpoint of base, full base and full height. And you'll notice the little green number 1 with the X next to it. That's where I'm going to click on the center of that yellow circle. So if I click on that now, come into the drawing area, it says specify base middle point. So on your object snaps down here on the status bar, you just want to make sure that your center snap is on. Mine is, that's all good, so I can switch that off again. So I'm going to click here like so, and that's the base middle point. Now when I do that and I start moving out, can you see the rectangle starting to take shape if I move the mouse? So I need to specify my full base value, which is going to be 62. So I pop that in there, press enter to confirm. So you can see now I've got my base, and now I need to specify my height. Now my height, my full height is going to be 12.5. So I'll pop that in there and press enter, and there's my rectangle. Quick and easy using that little circle. It's a really, really useful tool. Now we need to add some chamfers to the top corners in this front side view. So what I'm going to do now is go to the Modify panel, again in the Home tab on the ribbon, click on the flyout here, and you've got Fillet, Chamfer, and Blend Curves. Now, these all look the same as the AutoCAD ones. Click on Chamfer. It's somewhat different. The Chamfer kicks in, but it's all on the ribbon with a contextual Chamfer tab. So I'm going to select distance up here, first of all. First chamfer distance will be 5. Tab that down. Second chamfer distance will also be 5 as well. I want to trim the geometry. So I can switch that on or off. As you can see, trim geometry, don't trim geometry. I want to trim the geometry. But make sure that all of these are set to the right values. So we want 5 and 5, trim geometry. You can, when you do the chamfer, add the dimensions as well, and they'll go on the appropriate layers. I'm not going to do that. I don't want any dimensions in place. But what I'm going to do now is just hover here, click once there, and there's the little preview. Click again. Good thing is I stay in that chamfer command. There's no multiple required like in AutoCAD with the right click multiple setting. So I go there and I go there, get the little preview, click there, and enter to finish. That's how quick and easy it is. Now you'll notice when I press enter, it's just prompting me to do things in the chamfer command. You do have to hit escape a couple of times to cancel. Okay, just be aware of that one. Okay, let's have a look now at adding some more chamfers, fillets, using the tools in AutoCAD Mechanical. Now you'll notice here we've got some lines, and here we've got some nice arcs. We want these grooves here to be the same over here. So we've got to add some fillets. So we go to the fillet command, and you'll notice again, it's on the ribbon. So there's the fillet tab. The fillet distance will be 2. Now you can click on the down arrow and you've got some standard distances. So there's 2, so that's the radius. And again, you've got the trim geometry, insert dimension option. I just want trim geometry. And all I'm going to do here is just go 1 and 2 and 1 and 2. Just make sure that when you do this, it works appropriately. You want to get the appropriate part of the line each time. Can you see that? Otherwise, it just won't do what you want it to do. Now, you'll notice select object to create original length is kicking in there. Now, you'll notice, can you see, it's kind of weird how this works. It works in a different workflow to the regular fillet command. So I'm just going to hit escape a couple of times there, and I'm going to undo what I've done. So let's undo those. You can see that fillet worked fine there, but now I've got to go back and do another fillet there. So I've got to be careful how I do this. So let's go back to that fillet command and select first object. Just check your settings. You've got 2 and trim geometry in the ribbon up there. Select first object. So what I'm going to do now is I'm going to go first object here, second object there, and it does that. Now it says now select object to create original length. You don't want that. So you hit escape once like that. Make sure that you do that and then go back into the fillet command like so. Can you see that? Select first object or, and you can do polyline or add dimension there. Can you see that on the command line as well? But this is one where you do have to go in and select again. Okay. So it's 1 here, 1 here, and then select object to create original length. If I do that, and then do that, can you see it just extends it out, which is not what you want. So hit escape a couple of times, undo that last step, and I want to go back to the fillet again, and it's going to be that one here, then escape, fillet again, that one here, like so. Then it's escape a couple of times. So that's all our filleting and chamfering done. What I'm going to do now is I'm going to copy this view down, minus the circle. So I'm just going to select everything like that. And I'm going to do simply a right click and copy like so. And I'm just going to select the object. Now, hang on a minute. Surely I just selected that. Be aware that in AutoCAD Mechanical, when you do that copy, you then select the object, okay, like so. So nothing selected. Copy is just literally copy. It's not copy completely. Hit escape to deselect that command and go up here. And you'll see you've got power copy or regular copy, okay? Copy duplicates objects, then select the objects, right click to confirm, base point here on the center line. I'll just drag that down using the polar tracking to there and enter to confirm. and then just lose that circle. We don't want that circle there. So I'll just delete that like so. Now, all I want to do is trim and get rid of the bits on the side of the section. So our section is this side. We want to lose the right-hand side. So I zoom in, and I'm just going to use the regular trim command here. You'll see this trim there. I'm going to use that as the cutting edge. Right-click or enter to confirm. Trim these lines back here like so. Enter to finish. All these bits can disappear like that. Delete again. And then I'm going to put all of these onto the layer AM0. So I come here like so, AM0, and just hit escape there. And you can see now that I've got the contour lines on the section as if I've cut through the object. So you can see how quick and easy it is to utilize all of those core design tools when you're generating drawings in AutoCAD Mechanical. It doesn't take long to get used to them, but they are very different to regular AutoCAD. We're now going to be looking at configuring and activating our power snaps in AutoCAD Mechanical. Now, the drawing we're going to use looks remarkably familiar. That's because it's the drawing at the stage it was at the end of the last video. I deliberately didn't finish off the drawing completely so that I could show you some other things in this video, which include configuring and activating the power snaps. Now, the activating the power snaps is really important in AutoCAD Mechanical because what it allows you to do is work with dynamic input and preset snap settings. You'll understand what I mean when I show you. So make sure you download Cylinder Part 2.dwg from the library so that you can follow along with the video. Once you've done that, zoom in closely on the section AA at the bottom and just pan up a little so you've got a bit of space below it as well, like that. Make sure that you're only looking at that view so that we can see clearly what we're doing. So the first thing we're going to do is switch on dynamic input if it isn't switched on already. Newer versions of AutoCAD, dynamic input is on by default, but the icon down on the status bar isn't there, the little button that you click to switch it off and on. So we go down to the little 3 lines customization icon here. We go up to dynamic input, get the tick next to it by clicking on it, down to the little 3 lines again to switch off the menu. So there's dynamic input there on the status bar. Right click over it, dynamic input settings. We need to go in and edit our dimensional input settings here. Now you need to make sure that yours look like mine do. Okay, so we're showing the following dimension input fields simultaneously. Resulting dimension should be ticked, absolute angle should be ticked, angle change should be ticked. Ignore length change, ignore arc radius. We don't want those ticked. And note, you press tab to switch to the next dimension input field. So I can tab between those 3 that I've ticked. I click on OK, I click on OK, job done. So that's my dynamic input sorted. So we now right click anywhere in the drawing and go to options. And what we're going to do now is just set up our snaps, what they call the power snaps. Now, you'll notice when you go into options, there's a lot more tabs at the top of the dialog box. You want to go all the way along to the end. So you can see there's all those ones there. Use the arrows and go all the way to the right, and you want AM Preferences, which is AutoCAD Mechanical Preferences. Click on Snap Defaults, and you'll see that you've got 4 different setting types. You've got 2, and you've got 3, and you've got 4. We want settings 1. Like so, which means our object snap is on and we've got endpoint, midpoint, center, intersection, and nothing else. Our crosshair size is 5 and we're using the entity filter. If I went to a different setting, just keep an eye on the object snaps there, they change. If I go to 3, they change, okay? Just different preset snap settings to save you having to go in and change them all on and off all the time. So I want settings 1, my polar snap, make sure polar tracking is on and the increment angle is 90 degrees. I'm going to click on OK, job done. Click on OK again, job done. Now, we're going to have a little look at that section AA now, and what I'm going to do is a little bit of trimming first. So Home tab on the ribbon, Modify panel, there's trim right there. So I come into the drawing area, and where it says Select Objects or Select All, just press Enter to select the Select All. And we're going to trim back so that we tidy up this sectional view here. Now, all I want is this bit here and this bit here. So I need to lose that line there, enter to finish, and then I can select this line here and delete it like so. And then I want to hatch in this area here. So we've got a hatching there available in the drawing. Click on the down arrow, set it to hatching like so. Now, when you go to hatch in the draw panel, it's a bit weird in AutoCAD Mechanical. Click on the down arrow and you'll see that you've got all these preset hatches available to you. Now, if you don't want one of those, there's the hatch command. Click on the hatch command and we get the usual hatch creation tab up on the ribbon like you do in regular AutoCAD. I want ANSI 31 there, like so, and I'm going to use pick points and I'm going to change the hatch scale to 0.5 and press enter. I'm then going to come into this area here. There's my hatch, click, and it picks a point and there's my hatch there. Enter to finish. Job done. So that's the quick and easy bit showing the sectional bit in section AA. But what I want now is a physical shape of that hatched section. So what I'm going to do now is I'm going to go to the construction panel and I want to click on this flyout here and I want contour inside. Like so. Select additional boundary or point in the area. So go in this area here where the hatch is and click, and it gives me a lovely green outline of that contour inside. So this is where I'm going to use my snaps. Now I want to move that shape down. So I'm going to pan up a little bit, and then I'm going to go up to move up here. Now I've got move, copy and rotate, copy then rotate, and so on. Again, more new AutoCAD Mechanical, modify, move, etc. commands. I just want move, like so. Select the object, so I want the green polyline, click there, and enter to confirm. Now, if I specify a base point on that corner and click, as I come down now, watch what happens. Can you see I've got all these different points of displacement and so on, and it just looks like a regular kind of move. Now, it would be, because I'm just moving something in a regular way. But what happens if I just hit escape there, and I go back up to move, and I use something like move, copy, and rotate, for example. So I've got a choice now. I can rotate, or rotate, move. I want to do a move, rotate. Copy objects, no. So I'm going to select my polyline, like so. Enter to confirm. Still wants a base point. So I'm going to move it, like so. So I'm going to bring it down to there. Now this is where the power snaps kick in. So I click at that point there. Now I want the rotation angle, like so. Now all of my power snaps are kicking in because they're just there. They're switched on. I can power snap wherever I want to using those snaps that I've got in that settings one. So there's my rotate. I'm going to just rotate that up there by the 90 degrees based on the polar tracking snap that I set. Yeah, click there. Job done. Now it's asking me if I want to do it again, which I don't. So I just press enter to finish. And that's all complete. Quick and easy. Power snaps all on. Quick bit of tidying up on a section AA, and I've got my contour inside all set up as well. We're starting another exercise now in AutoCAD Mechanical course, and we're going to be having a look at adding some center lines and holes in AutoCAD Mechanical. We're going to use those center lines and holes to work on a little drawing of a small motor. Now, the drawing is there on the screen in front of you. It's called motor_centerlines.dwg. As usual, you can download it from the library to follow along with the video. Now, sometimes when you're working in AutoCAD Mechanical, you don't have that structure of all the parts and the assembly. So the mechanical browser can actually be turned off to give you a bit more screen real estate. So let's just jump up to the View tab. And mechanical browser is over here in the palettes panel. Just click there. Gives you loads more space to work on the screen, as you can see. So we're in our motor center lines drawing, and what we're going to start looking at is placing things like center lines and holes into this little motor drawing. So jump back to the Home tab on the ribbon first. And what we're going to do is we're going to go to the Draw panel and we're going to draw a center line. Now you'll notice there's some other commands available as compared to regular AutoCAD. If I click on this flyout here, I can place a center line cross, a center mark. There's all different types of center lines. And the one that I want is a center line cross, like so. So I come into the drawing area. It's now asking me to specify the center point. Now the center point is going to be the center snap in here. Now just check your object snaps down here. Go down to the down arrow, make sure that center is on. Like so, there's center there. So just make sure it's on so that you're obviously able to select the center snap on the circle. So when you touch on the circle, center snap appears, click, and there's our center. Now what's really nice is I can drag this out as far as I want. And what I'm going to do is I'm going to come up to the quadrant here and click like so. And you'll notice that even though I've clicked on the quadrant, the center line has extended past the circle. Now that's really useful, but what's even more useful is it's gone on its own layer. If I select that, you'll notice that's on layer AM7. That's what I love about AutoCAD Mechanical, all of these preset layers as per the objects you place. Now we can change that overshoot setting for the center lines. I'm going to right click in the drawing area with nothing selected, go to options, and what I'm going to do here is go back to the top of the dialog box. This time we want AM standards, AutoCAD Mechanical standards, and you'll see that we've got center line right there like so. So when I select center line like that, what I can do is just double click it. And it's got all the settings in there, and it's using a particular standard, as you can see, ISO 6410 in 1993. So there's my overshoot length, and it's fixed, and it's a fixed distance. So what I'm going to do is I'm going to change that fixed distance to 3. So put 3 in there like so, click on OK, apply, click on OK. And what I can do now is I can edit the center line by double clicking on it like that. And as I come back up, look, can you see this is really neat in AutoCAD Mechanical? I love this with center lines. I've double clicked on it and it allows me to go back to that quadrant. When I click again, can you see the overshoot is smaller where I've made the change? How neat and tidy is that? Saves so much time. I so wish that we had that in regular AutoCAD. Wouldn't that be lovely? So, quick and easy with the center lines there. Let's draw a straight center line now in the side view. So we're going to look at the side view over here. So again, zoom in, utilize that real estate you've got where the mechanical browser isn't there. So the center line I'm going to create is between this line and this line here of this polyline. So I'm going to go back up to the draw panel, click on the flyout, and I just want a regular center line this time. And I'm going to specify a center line starting point, which I can use the midpoint there. And we're going to go across here to there like that. Click on that midpoint there. And again, that overshoot now is set to 3 for all center lines based on the settings I changed. So there's my center line in place. Now we're going to go up to the layers panel, click on the flyout here and just pin this open. Now there's lots and lots of different icons for layers in AutoCAD Mechanical. But what I really like is you can switch on your construction lines, which are there like so. Construction lines on or off, and these are the construction line layers. So you can see there that they are AM_CL. So I click there like so, and there's my construction line. And what we're going to do, we're going to develop this little point here off of the side view on the motor over here on the front view. So pan across a little bit. And again, all I'm going to do now is create a centerline cross with a hole on this intersection here. So how do I do that? How does that work? Well, what I've got to do is go to the Home tab again and on the Draw panel. And what I want to draw is basically a centerline cross with a hole. So that's off the centerline flyout here. Centerline cross with hole like that. So I click there, specify the center point. So I'm going to snap to that intersection and left click. And then I'm going to specify the diameter of the hole, which is going to be 6. So 6 and enter. And there's my crosshair and my hole in place. And what I can do there now is do another center point. If I want to, click there. And the next one will be 7. And what'll happen is it'll place another one, or will it? It won't, because it's already got one there. So what I've got to do now is hit escape a couple of times. I want the construction off now because I can utilize the center point like so. So let's zoom in on that a bit tighter like that. Make sure that we've got the center point really easy to see. So we go back and we go center line cross with hole. I come to here like so, get that midpoint and click. And then the diameter of the hole will be 7 this time. And as you can see, it places one on top of the other. Now, press escape a couple of times. You can see that we've got some crosshairs all over the place here. So I can click on one of them and I can now delete that. And I can come back this way, click on one of them, delete that. And also that other vertical one, I don't really need it. I can click there and I can delete that. They're individual objects at the end of the day. And you'll see that there's quite a few there where I've placed all the holes. And I've just got to keep clicking because unfortunately I've placed them on top of each other like that. But once I've done that, there's a nice neat hole there in place. And that's how quick and easy it is to place center lines and holes in AutoCAD Mechanical. And you can see those tools are really, really useful. There's some massive time savers in there. That center one, where we place the center at the beginning with the overshoot, I so wish that was in regular AutoCAD. It's such a cool tool in AutoCAD Mechanical. We're starting another video now, and we're going to be looking at creating and using construction lines in our AutoCAD mechanical drawings. Now, once again, we've got a new drawing for you in the library. It's called lines_construction.dwg. And what we're going to do here is create some automatic construction lines. Now, this is a lovely feature of AutoCAD Mechanical. It takes away a lot of the donkey work when you're creating construction lines. And what I love about construction lines in AutoCAD Mechanical is they go on their own layer as well, and you can turn them on and off really quickly and really easily too. So let's have a look at how we develop these construction lines in AutoCAD Mechanical. So we're in the drawing. We've got a couple of views over here on the left hand side. So the first thing we need to do is develop our projection crosshair. Now this gives us that 45-degree angle that allows us to project from, say, the top view here across and down so that we can line it up with this view here. Now, it's a very quick and easy tool in AutoCAD Mechanical. In regular AutoCAD, you would have to draw all of this manually. Just be aware of that. And you can see how much of a time saving it is if you're working in AutoCAD Mechanical. So I'm going to go up to the Home tab on the ribbon. I'm going to expand out the construction panel and pin it open like so. Now, I want this little icon here, which is the projection icon. So I click on projection, come into the drawing area, and do I want projection on or off? Well, I want it on, obviously. And there it is there. So there's that 45-degree line. It's not in the right place right now, but I'm going to utilize this endpoint snap here and just drag to the right, and using my extension snap, I'm going to type in 20 units to the right. Enter. So that places it, and then the rotation angle, I'm going to say I want it to be 90 degrees, and enter, and lo and behold, I can now project across to this 45-degree construction line and back down this way. Now I'm just going to zoom out slightly because the next bit is just very, very cool. I think these are great. Automatic construction lines are wonderful things in AutoCAD Mechanical. They save so much time, especially when you've got a slightly more complex shape like this one here. So we go up to construction lines, and we want automatic construction lines here. And I've got different construction line creation methods. I want this one here. So I'm going off to the right, basically. Those are the red bits there. Click there, and I select the objects that I want the construction lines to come from. So I'm going to click here, drag a window selection over that particular view and click. Same again on the lower view, click and drag over that view as well, click again. And then I'm just going to press enter and watch what happens. How absolutely wonderful is that? It projects across to the 45-degree line and down, and it projects across from the lower view across those lines that I've projected downwards. So I've now got the ability to zoom in on this area here, and I can start developing my other view. Now, I'm not going to take you through the whole view. I'm just going to add an outline and a center line for now from this hole here. We're going to have a center line going across as well. But the idea being is I've now got every single intersection that I need to develop that other view. Now I'm just going to hover over this line here. Now I'm just going to check, obviously, what this particular object is. Now if I click on it, right click and go to properties, that's the quickest way. Sometimes when you hover in AutoCAD Mechanical, you don't get those little tooltips come up, so just be aware of that. So I'm going to click here, and it's on layer 0, as you can see there. So I'm just going to leave everything on layer 0. Nice and easy. I'll close the properties there. There's layer 0 already set up in the layer dropdown. So I'll hit escape to delete my rectangle. Now the benefit I have is I've got all my intersections. So I want to draw a rectangle, and I'm just going to use the regular corner to corner rectangle, that one there. Click there, and I'm going to go intersection here up to my intersection here. Job done. Quick and easy. Now what I want is a center line. Now the center line that I want to place is quick and easy as well. All I need to do there to place the center line is object snap to the appropriate intersection points. Remember, the overshoot goes in automatically. So I just need to be careful which ones I choose. Let's just check. There's my center line there. So it's going to be this construction line here. So I need the intersection point there and just there. So I go up to center line. There's my center line command. And I want to go from this intersection over to this intersection. Now, if you want to make sure that that is an intersection, just do the shift and the right click, use the intersection there, and make sure you get the intersection snap right there. And there's the overshoot in place as well. Now, you don't have to delete all of those construction lines. I can go up here to my layers panel and I can switch my construction lines on or off, you'll notice. So there's construction lines there, on or off. So if I click now, turns them all off, and I can zoom out, and there's that third view starting to be developed in my lines construction drawing. How lovely is that? It's so quick and easy. If I want those construction lines back, go to the layers panel, just click on the toggle there, and all the construction lines come back again. How fantastic is that? So quick and so easy. So make sure that your construction lines are obviously off, like so, and then you can continue developing that view, or if you need the construction lines for any intersections, just put them back on again. We're starting another video now, and we're looking at drawing with some of the different line tools available to us in AutoCAD Mechanical. So we've got a new drawing for you. It's called lines_designing this time, because we're designing rather than creating the construction lines. As you can see in the drawing, the construction lines are already set up for you in this particular instance. So what we're going to do, we're going to create part of a right side view of a part, add a section plane line, and then add a breakout line as well, just so it all sits nicely in the drawing. And then what we'll do is we'll turn off the construction lines so you can see the results of your endeavors as well. So we're going to draw this right hand view here where we've got this center line. And what we're going to do first of all is draw a right hand part of the section, but use the center line as what they call a symmetrical line. So let's have a look at that. We go to the Home tab and onto the Draw panel. And then in the line drop down list here, you'll see that we can create a symmetrical line. This is clever stuff. Again, it takes a lot of the donkey work out of the repetitive work that you might have to do in AutoCAD. So symmetrical line like so. It says select existing center line or first point. Now what you need to do is click anywhere along that horizontal center line here. So anywhere along here. So ideally go for something like an end point or a midpoint if you can. If your midpoint snap isn't on, do a shift and a right click and just go midpoint like so and get the midpoint click like that. Now that actually asks you now for a start point. Now you're going to start drawing your line. So you'll notice we're on the layer AM0, which is excellent. That's the outline layer, the AutoCAD Mechanical outline layer. And we're just going to start working our way along these intersections. So the idea will be that we come up and we're coming up here like so, and we're just clicking and along to the intersections like so. Up again into this little notch. And again, can you see what's happening on the other side of the center line though? Isn't that really rather clever? So we're coming in here. And then we've got the notch at the top coming across, and we're going to kind of repeat what we were doing on the other side. So I come down to here, into here like so. And if you've got any symmetrical parts to draw, the lovely thing about this is it's done like that. So we've got to that point there. So what we need to do now is press enter and job done. Look at that. Isn't that wonderful? So that's how you can create those symmetrical lines. Now, what we're also going to do is add a section there as well. So what we want to do is add a section line on the left-hand view. Before we do that though, let's lose those construction lines. Go to the layers panel, click on the flyout, just toggle off the construction lines like so. It's a darn sight easier to see things that way. So let's have a look at placing a section. So we're going to go to the Home tab again. And we need to go to the detail panel here, like so. Now there's lots of different commands in here, hide situation, breakout line. We want section line. that one there. So we come in and it's asking us to select a point. So we're going to object snap to the top and bottom endpoints of the vertical center line in the left-hand front view. So I'm going to snap here, endpoint, snap here, endpoint, like so. So I've snapped there like that. And then I press enter. And that will allow me to select the symbol, which is there. So we now need to specify the first section symbol, which is going to be A. So we can just press enter there, like so. Specify side of section. Now we're looking from the left to the right in this case, because the sectional view is on the right hand side. So we need our section on the left hand side like that. The arrows need to point from left to right. So we click there like so, and they go in. Specify origin of section view. Now, when we do this, we need to click under the right-hand side view. So we're going to go over here somewhere, and ideally maybe hover or come down here, use your object snap tracking, anything like that. Click like so, and there's your AA marker. Now, obviously it will start at A, section A. If you do another one, it will go to B and so on. But as you can see, that's a really quick and easy way of adding a section with those line tools when you're working in AutoCAD Mechanical. Starting another video again in this particular chapter, and we're going to be looking at another drawing which is called features _ holes and slots.dwg. Download it as usual from the library to follow along with the video. Now, obviously we're going to be looking at standard features now, as the drawing suggests, and we're going to be adding some holes and some slots and things to our particular drawing. So you'll notice here we've got two views. We've got a plan view and a side view with a construction line going down through sort of off of the middle to the left there. And what we're going to do is we're going to add some holes and some standard slots. Now you'll notice we've got a top plate here. We've got a middle plate in there, can you see? And then we've got a bottom plate as well. So we'll need a slot to go through there where the screw is coming down, or the bolt perhaps is coming down through along the sort of construction line there vertically. So what we're going to do is we're going to go and set all of this up, put it on the right layers, and use some of what they call the features, the content libraries and the details that come with AutoCAD Mechanical. So we're going to change the current layer to a hidden layer initially by going to the Home tab. We're going to go into the Layers panel. And what we're going to do is go to the Mechanical Layers drop-down list. Simple and easy. And we're going to select AM3. And that is a specific hidden detail layer. You can check that in the Properties Manager here. So there's the Mechanical Layer Properties Manager, and you can see there that it's a particular line type, 0.25 millimeters, and that AM ISO 02 line type there is a dashed line type. It's a hidden line type. So I'll click on Cancel there now. So let's have a look now at adding a countable hole for an M6 regular thread bolt. We're going to go to the Content tab. So this is where we've got all these amazing bits of content that we can add to our mechanical drawings. So we're going to go to Expanded Holes, which are in the Holes panel. So all of our expanded holes here are in this holes panel. Now, when I say expanded holes, I mean an expanded library of holes that you can use. So I'm not saying you're expanding the hole by making it bigger, I hasten to add. So you've got this expanded library of all different holes that you can place in your AutoCAD Mechanical drawings. So we're in the holes panel now, and as you can see there's lots of different ones. So if I look here, got things like countersink and counterbore and so on. We want countersink, so I'm going to insert a countersink from the content library, and all of these are in the library that comes with AutoCAD Mechanical. So I click on countersink, and what will happen now is I get the library coming up, and this is absolutely wonderful because all of this is ready to go. So what we can do now is we'll expand out holes here, and we've got all different standards of holes, and we want the ISO countersinks, International Standards Organization countersinks, the metric ones. And we want a front view, that one there. So I click on front. So what will happen now is I get to select the size of hole based on a particular type of screw. So what we're going to do here is expand this out. So we need to select a particular type. Now there's all different standards here, and we want an ISO 70461 1994H regular thread. So we want that one right there. And now we've got a choice of front or side. We want the front view, obviously. So I click there. And now what I can do is specify what I want here as well. So do I want a metric thread? Do I want a user countersink? I'm just going to go for metric thread like so. And as you can see, it jumps from library page to library page. And this is that expanded library that I was talking about. So in the screw connection dialog box now of the standard sizes, we need an M6 like so. And then what we do is we click on next. Now, it specifies the start point of the hole. So I'm going to zoom in on this view here, and we're going to go down to this intersection here, and then this intersection here. Now, if you want the intersection, do a shift and a right click just to make sure it is the intersection, like so. And there we go. So there's our screw assembly ready to go like so. Now, we need to complete the definition of the hole. So in the screw assembly location front view, we need to specify where this is all going to go. So we need to just click on next because we're accepting all of those default values first, like so. And then we've got the assembly grip representation. So this is where it's basically going to represent something. Do you want a normal one? Do you want it as hidden detail? Do you want a sectional view? And so on, or just no. The no means that there's nothing there. You just look at it as if it's real side-on view. We want hidden. I'm going to select hidden in this case. And then click on finish. And what it'll do is it'll go through the library now and add all of that to my hole there, like so. So there's my countersunk hole in that AM3 layer, the hidden detail layer. Now, we need to add a slot to this part as well. So we've added the hole. We need to add the slot through here now. Now, in order to do that, we go to the Content tab again, into the Holes panel, and we need to select a through slot. Now, if you look, you've got a through hole, a blind hole. If you work your way all across these, there's all different ones, external threads, counter bores, and so on. Blind slots, and there's through slot. But we've got things like external threads that are tapered and all different types of settings here, and all of these go to that expanded library. So I want this one here, a through slot. And as soon as I click on that, again, the library kicks in. So I expand the through slot there like so. And what we want in this case is in the selector slot dialog box, we need the ISO normal 1 because we're using ISO. It's obviously, you know, metric. So as I come down, there's lots and lots of different ones. You want to go to ISO normal 1, that one there. And what we're going to look at again is we want the front view because we're looking in a front view like so. And we want to specify the insertion point. So we're working our way down that construction line. So we want intersection there. And then we want this intersection as well. Again, shift and right click if you want to make sure that it is the intersection snap. So I'm going to go to there like so. Now, there's the slotted hole in plan. We need it to be, obviously, an M6 again, because we're using an M6 screw. And then all we've got to do there now is make sure that we click on finish, like so. And now, can you see, we can drag the size, and the size of the slotted hole for that particular screw, we're going to make it 18 and press enter. And there it is there in place. How wonderful is that? We've got the center lines, everything. It's all in place. And now what we're going to do is add a tapped hole to that part in this section here. So there'll be a tapped hole. So we're basically putting a screw through this plate, through the slotted hole, into this thicker plate here. So we're going to do the same again. So we go to the Content tab and the Holes panel again. And this time we want a tapped blind hole, this one here. And again, the library kicks in like so. We expand it out like so. And what we want again is we need to specify which type of tapped hole. And it's going to be an ISO 262. So just scroll down the list. There's the ISO 262. Do you want a fine thread or do you want a regular thread? Well, we're going to go for regular, like so. We want the front view again. Specify the insertion point. So what we're going to do this time is we're going to specify, I'll just pan up a little bit. We're going to go from here, this intersection, and then we're going to come down here to this intersection. Again, shift and right click if you want to make sure it's an intersection on the override snaps. It's always a good habit to get into, like so. So that's in place like so. M6 again for our screw, and click on finish. And it'll add that in place, and then we just specify how deep we want that to go. So that's entirely up to you, and we'll just drag it down, make it fit, or put a value in the box like that. So I guess we could get away with something like 14 there, let's say, and press enter. And it places everything in our panel like that. So everything's in place. So our panel of objects there, we've got plate, slot, plate. So it's all paneled together and is nice and neatly in place there with all of the holes and so on. Now, if I just zoom out slightly, what we need to do as well is mark where that hole is in the plan view. So we're going to go to the Home tab and the Layers panel now. So I'll close the holes there. That goes back into the ribbon, into the Home tab, into the Layers panel. And we're going to make the AM1 layer current now because we'll be able to see this. It's not hidden detail. Now, we could use AM1 if it was there. I don't have an AM1 layer. So what I'll do, I'll just use AM0. That's for contours there, like so. And you could use that or you could create an AM1 layer. It's entirely up to you. AM1 is another definition of a layer that you would use for what I call solid continuous lines that you can see, whereas AM3 tends to be that magenta dashed line type that you can see on the drawing at the moment. And what we're going to do now is we're going to go to contour. Now, if I go to contour here, you'll notice there's different ones that I can use. If I use that second contour there, like that, surprise, surprise, there's that AM1 layer. Now, that's a really nice drop down because it creates a new layer for you because you're just working on a particular contour layer, which is a solid layer in this case. And as you can see there, it sets AM1 by default as the current layer. Really, really useful if you need it. Now, what we're going to do is we're going to create a standard hole in another view. So what we need to do is go to the Content tab again and into the Tools panel this time. And what we're going to select is Power View, like so, and come into the drawing area, and we need to select our object. So what we're going to do is select the counter bore hole just here on this view, like so. Which view of the screw connection should be drawn? We want the top view, and the insertion point, well, we need that ideally up here somewhere. So we need to place it in the middle here. So I'm going to hover there like that, come across. When I get the intersection there, just left click, and there's my hole. How quick and easy is that? And that's what I love about all these features and holes and slots in AutoCAD Mechanical. Everything is automated and parametric. You don't have to worry about creating those center lines, creating those holes. It's all in that expanded library of content in AutoCAD Mechanical. So one more thing to do, Home tab on the ribbon, go back to our layers here and just switch off the construction line. And then you can see exactly how accurate, neat and tidy that view of the hole in those plates is. For this particular video, we've got an exercise file called pump001_subassembly.dwg. As usual, you can download it from the library to follow along with the video. As you can see, it's a simple pump subassembly with some balloons and a parts list. What we're going to look at, though, is the new break at point command available in the latest version of AutoCAD Mechanical. Now, you will find that there are two different ways of breaking lines at a point in AutoCAD Mechanical. I'm going to show you the actual AutoCAD Mechanical one first. So you go to the Home tab on the ribbon, and you go into Modify here, click on the flyout and just pin it open. It's much easier that way. It doesn't keep disappearing back into the ribbon. And you've got here AM break at point. So if I select that, it breaks it at one point, and I can specify the cutting point I want to break at. Just before we go any further, I'm going to jump into the object snaps on the status bar and make sure that midpoint is selected, like so. We're then going to zoom in on this line here, top right, just pan down, and I'm going to select that midpoint there on the line, like so. And then I'm going to select the entity I want to break. So can you see there, it's already highlighted that line, so I can just press return now. And that'll break that line into two lines. So if I select it now, you'll notice it's asking me to specify another cutting point. I can't go and select that line yet because I'm still in AM break at point. So just hit escape a couple of times and then click on the line. You can see there's one line there and one line there. So what we've done there is we've broken that at a point using the AutoCAD Mechanical break at point command. I'm going to hit escape there a few times and click on undo on the arrow here. And you can see there, I'm going to undo that group of commands there, and it will take me back. And when I select that line now, it's a whole line again. I've undone it. What I'm also going to do is I'm going to unpin the modify panel. And then what I'm going to do is zoom in on the line again, like so, and I'm going to type a command this time, which is the regular AutoCAD new break at point command. So you type break at point, like so. Now, you can break at point in regular AutoCAD anyway, but there's a slight change to it. If I press that like that, it says select object. So I want to break this line here at a point. I then specify the breakpoint. So you'll notice the workflow is different to the AutoCAD mechanical command. And you'll also notice I don't have my midpoint snap on because I've undone it and I'm not using the AM break at point. So I need to switch midpoint on, lose the menu and pick the midpoint there, like so. Now you'll notice I'm out of the command. AutoCAD mechanical break at point, I stay in the command until I hit escape. You'll notice now I can select like so. Now, the benefit I have here is if I press enter now, it will repeat the break at point command, the regular break at point command. So by pressing enter now, I can just go straight back into the regular AutoCAD break at point command if I need it. Or the preference might be that I want to use the AutoCAD mechanical break at point command. It's up to you. They both perform the same function, but slightly differently. I'll just hit escape there a couple of times, make sure that I undo the command that I did last, which was break at point, there like so, and then I'm going to double click on the wheel, just to zoom extents, and when I select that line now, it's a whole line again, like so. So we're back to where we started from now in the Pump 001 sub-assembly drawing. We're starting a new chapter now in our AutoCAD mechanical course, and we're going to be looking now at manipulating the mechanical geometry in our drawings. So we've got a new drawing open for you. It's called weld_flange001.dwg. You can download it from the library as usual to follow along with the video. And in this video, we're going to be looking at some basic editing tools that are available and just basically make your life a lot easier and more productive when you're using AutoCAD Mechanical. So go to the Home tab on the ribbon first of all, and we're going to go to the Offset command on the Modify panel. So there's Offset. Come into the drawing area. It asks you for an offset distance. Go down to the command line and click to get the cursor flashing, and then type 5. And then what is known as the pipe symbol, which is like that vertical line, like that on the keyboard. It's normally operated when you press shift down somewhere on your keyboard. The next number after the pipe symbol is 22.5, and then another pipe symbol. And then I'm going to put in 24, and then another pipe symbol, and then I'm going to put in 39. So what I'm telling AutoCAD Mechanical here is that I want 4 different offsets at the same time. If I now press enter to confirm those, it'll prompt me now to select the object to offset. I can use my dynamic input with the pick box to do that. Click on the circle, move inside the circle, click again, enter to finish. There's all my offsets all in one go. Isn't that amazingly quick? Saves a lot of time with the multiple offset distances. We're going to zoom in on this top view here now in our drawing, and you can see that this view hasn't been finished off properly. So we want to join the top group of lines here. Now I'm going to go to the Modify panel again, click on the flyout and just pin it open. And I want this command here, join. So it connects non-parallel lines, polylines, arcs and circles. So if I click on join, it says select first object. If I select this line here, followed by this line here, it'll join them together. So that closes that gap. Let's do one more. Let's do another join. So I'll do this one here, followed by this one here. And you'll notice it removes bits of lines as well. Very useful. So that's tidied up that view nice and neatly like so. So what we're going to do now, we're going to do some copying of the view we've just updated. I'm going to put version 1 and version 2 over there. So we're just going to copy them straight across just using the intersection of the center lines. So all we need to do there is select all the objects. So what we can do is we can go up here to the Modify panel again and just select the regular copy, not the power copy, but the regular copy. Just duplicates objects. Select everything, get it all in the window selection like so, enter to confirm. I'm going to copy now using the intersection there. And using your polar tracking, just take it across once to there, version 1, and then over here to version 2, click again like so, enter to finish. So we've got 3 now. And what we're going to look at now is scaling, and we're going to use the AutoCAD mechanical scaling tools. Now these are really, really clever. So I'm going to scale in one direction. It's called Scale XY. And I'm going to go down to the command line and I'm going to type in AM Scale XY. So it's AM Scale and then XY. Can you see that? Now what you'll find is that this is not available on the modify panel. You'll find you have to type it in. So it's AM Scale XY. So you can select it there on the suggestion menu. And what it'll do now is it'll ask you to select the objects. So what we're going to do is we're going to select all of the version 1 geometry here, like so. So click, get all of the geometry, including the center lines like that, and then press enter to confirm. Now we're going to select the midpoint of the vertical center line. So that's going to be right here, like that. There you go. So midpoint of vertical center line. Click there. And then what we're going to do when prompted for the scale factors, with the x-axis scale factor is going to be 1.25. 1.25. That's the x-axis scale factor. Enter. The y-axis scale factor is going to be 1.00. When I press enter, you'll see that it's made it bigger in the X direction. Let's have a go on version 2, but do it in the Y direction. So I'm going to right click, repeat AM Scale XY, select all the objects like so there, enter to confirm. Same midpoint again here. So get that midpoint, click there, and the X scale factor this time is going to be 1.00, and the Y scale factor will be 0.75. After each one, press enter, and you'll see that scales in the Y direction. It's really quick and easy to do. So it's AM Scale XY. When you type that in, it allows you to scale in both the X and the Y direction in separate values so that you can obviously scale in different directions. So there's some basic editing tools for you in AutoCAD Mechanical. In this video, we're going to have a little look at some of the power commands available to us in AutoCAD Mechanical. Power commands are more sophisticated commands than your regular AutoCAD. They're automated and somewhat parametric and allow you to automate some of the regular drafting, annotating and editing processes in your AutoCAD Mechanical drawings. We've got a new drawing for you. It's called power_commands.dwg. As usual, you can download that from the library to follow along with the video. So we're going to zoom in on the bottom right corner of the title block first. And what you'll notice, the drawing number just has a dash in it. I'm going to double click on the title block, and due to the way that the standards are set up and the templates are set up in AutoCAD Mechanical, I can automatically change my title block entry. So in my drawing number there, I'm going to delete the dash and I'm going to put 001-1983, for example. When I click on OK, you see I've power edited the drawing number in the drawing. Double click on the wheel to zoom extents, and then I'm going to double click on the drawing border. And this is where you notice that you've got the drawing borders with the title block. These are applied to your drawings based on the standards that you've got set up in AutoCAD Mechanical. I'm not going to make any dramatic changes there, just click on OK, but now you know how that works, okay? So that's how you find your drawing borders with title blocks in AutoCAD Mechanical. I'm going to zoom in now on the top right part of the top view. So I'm going to zoom in here. And you'll notice we've got a 135 dimension with tolerances. Now, if I double click on a dimension in AutoCAD Mechanical, you'll see that we go into power dimensioning, which allows me to add things like fits and tolerances, dimension text, representation, and so on. Tolerance is highlighted. If I turn it off, we lose the tolerance. Click on Close Editor. It's now just a regular 135 dimension. I'll zoom out slightly, pan across, and then I'm going to zoom in on these radii going around here. There we go. See, there's 4 of them, and they're all radius 10. I'm going to double click on this particular fillet here, like so. When I double click on it, you'll see I can do a power edit and change the fillet size. I'm going to go for 2.5 and then click on OK. As soon as I do that, I now have to highlight where I want that new fillet to go. It's taken away the old one. If I hover there and click, There's the 2.5. I'm just going to put the radius 2.5 in the middle like that. And then all I've got to do, again, in the Power Dimensioning tab up here, click on Close Editor, job done. Now, I want to change these three. So what I'm going to do is I'm going to go 1 and 2 and 3. And when I just press Enter now, you'll notice I can enter an option. I can accept the fillet command, or I can go to the next command. I'm going to accept, like so. And the fillet size now is, again, going to be 2.5. Click on OK. Select the objects. So I can just go around and select the objects each time. So if I select that object and that object there, and then press Enter, they update again, and I can now do the click on the lines thing again. There's 1 and there's 2, like so. Enter to finish, job done. Really quick and easy, and I really like that one because it allows you just quickly to go, oh, I did that one and now I want to do those as well. And it allows you just to quickly speed through the command and work with it really quickly. So that's a really useful tool. Now, what we're going to have a look at now is the Power Erase command. So in the side view, let's zoom out. Side view is down here. We've got various dimensions available to us. So we've got 70, 35, and so on. What we're going to do is we're going to select this dimension here, 35, and also this dimension here as well, 71. Now, what we want to do is we want to power erase those both. So as you'll notice, as soon as they're selected, it goes to Power Dimensioning. We need to go to Power Erase first and then select the dimensions. So just hit Escape a couple of times, takes us back to the ribbon. We go to the Home tab and into the Modify panel. There's your erase command there, but it's Power Erase. So when I click on it, it'll allow me now to select the 35 and also the 71, like so. So if I select those and then press Enter to confirm, you'll see it drops the 70 and the 95 in and tidies up the dimensions for us. It's a really, really nice tool. So you can see there's some really, really neat editing commands. Just double click on the wheel to zoom extents, as is standard cat practice, so you can see all of your drawing, but you can see how quick and easy you can get in and automate workflows and processes when you're working in AutoCAD Mechanical. We're going to be looking now at creating and editing what they call associative hides. And what we're going to create is an associative hide situation of non-structured geometry of free objects. Now that might sound really complex. It's not. What you're doing is you're hiding situations of assemblies in your AutoCAD Mechanical drawings so that you can kind of see the wood for the trees. So we've got a new drawing for you. It's called Workcell 001 Conveyor. Download that from the library to follow along with the video. And the first thing we're going to do is we're going to go down to our status bar and verify that mechanical structure is on. Now that's this icon here. Mechanical structure needs to be on. Okay, I can switch it off like that. And it says it cannot be turned off while structure entities still exist in a drawing. Now, when I say structure entities, we're talking about the mechanical browser. So I'll close that. I'll go down here to workspace switching and go to structure. And what you'll find is the browser opens up and we also get this, what they call structure catalog. You can ignore that, that can be closed. But we get the mechanical browser. Now I could have very easily just gone to the view tab on the ribbon and switch the mechanical browser on here in the palettes panel if I wanted to. So it's entirely up to you which way you do that. Now, what we're going to do is look in the mechanical browser and review the structured definitions that have been added. So we've got the Workcell 001 conveyor, and if I expand out the footplate here, we've got a side view as well, and there's our main Workcell 001 conveyor. Now, what we're going to do in the browser is right-click on footplate 1. So let's right-click there. And what we're going to do is we're going to delete it. So if I click on delete, like so, you'll end up, well, I select footplate first and say yes, obviously, but then we end up with Workcell, conveyor and main, like so. Now on the status bar, we're going to go now to the mechanical structure toggle and turn it off down here. So we'll turn that off now, like so. So that's off. We turned off the mechanical structure. Now, that we couldn't turn that off before. And the reason we can now turn that off is there's no structure there. All we've got is the drawing. There's no structure anymore. So we're going to zoom into the left leg in the front view, which is just here, like so. Let's get zoomed in on that nice and tight like so. And what we're going to start is creating an associative hide situation for the geometry that represents this adjustable leg support. So can you see we've got the lower part of the leg and the upper part of the leg goes in and out. It's adjustable. The height is adjustable. So what we're going to do is we're going to click on the structure tab on the ribbon like so. And then what we're going to do is go to the hide situation panel and click on create. So we need to create a new hide situation. So it's just here, create, like so. Come into the drawing area now. And for the foreground objects, we're going to select the rectangle of the lower channel, bolts, washers and hole as shown. So that's all this information down here. So can you see we're going to select the channel, which is that bit there, the outer bit. And then we're going to zoom in. And what we're going to select is this bit here and also this hole here. And if I just pan up a little bit, also this one here as well, like that. So we're going to select those like that. So they're the ones that are basically going to be hidden. So right click after selecting them, like so. And you'll see now that we've got a hide situation and it appears in the mechanical browser as well. Now we're going to remove the automatically selected objects from level 2. So in the hide situation dialog box, we're going to, in the tree view, below level 2, click free objects like so, right click and remove like so. So they're gone. And to specify the objects that you want to have in level 2, in the hide situation dialog box, we now click on select objects. Okay, which is just up here. So we've got new level and also we've got select objects just there. So make sure level 2 is selected and you want select objects. Takes you into the drawing now. And in the drawing window, we're going to select the outer lines of the top channel and the 4 slots shown. So zoom out a bit, pan across. There's the outer line there. So we want those 4 lines and we want the 4 slots. So zoom in. You want 1 and 2, the line at the top, 3 and 4. There's the lines going around, and then we want the slotted holes, and there's 4 of them. So there's 1 there, 1 and 2, 3 and 4, like that. And then when you're done, right click after selecting them and they get added. There's our free objects added, and you can see they're highlighted now in the view like so. And we can add a third level to the hide calculation if we want to. So what we do is we click here now, we want another level, so that's level 3. And what we're going to do there is we're going to add the square tubing to level 3. So again, we need to select objects. So we select level 3, select objects, and we want the square tubing. So that's these bits here, 1 and 2, like so. And again, we right click and that takes us back. Now at the moment, the hide situation needs to be renamed. So I'm going to go to hide here. I'm going to right click and rename it. And what we can do there is just type in the new name, and it's going to be leg front left. And then a dash and then front left like that. Press enter to confirm. So we've got a renamed hide situation in there now. And what that means is that hide situation is done. So we can click on OK and that's all in place. That's our hide situation. Now, do you see what's happened there with our hide situation? It's now hidden because it's hidden detail. That's the whole idea of these hide situations. Now in the browser, we can review the inclusion of that here. There's our hide situation, hide, hide, hide. There's leg front left. So there's leg front left. And when you highlight it, there's the hidden situation behind the detail. The whole idea is it puts it all on hidden detailed dashed lines, and it's a hide situation because it's hidden behind the objects, as if you were standing there looking at it in real life. And that's how you create one of these associative hide situations in your AutoCAD mechanical drawings. In the previous video, we looked at creating and editing associative hide situations. We're going to look at that in a bit more detail in this particular video. We've got a new drawing for you to do it. It's called mechanism001.dwg. As usual, download it from the library to follow along with the video. So this exercise assumes that the workspace structure is active and that the structure selection order is set to top down. So down to the status bar, into workspace switching, and we want structure. So let's set that first. you'll see the mechanical browser kick in, and you'll also see your structure catalog. You can close your structure catalog by clicking on the cross there like that. So we can see our mechanism 001. Now I'm going to minimize that to there like so. And when I hover over the drive system, you can see it's highlighting everything there. Now, I don't want everything highlighted, and we'll work on that in a moment. So what we're going to do, we're going to expand all of this out like so, and I'm going to select frame 1 like so, and then I'm going to hold down Control and select sprocket bracket base 1 like so. And then while I'm in the browser now, I'm going to right click on frame 1 like so, and click Property Overrides. That'll bring up a dialog box, and we just want to make sure that we override the properties like that, and make sure that our center lines are ticked. We want to override that. So basically our center lines are ticked. Anything over on the right hand side you can leave unticked. So what I'll do now is I'll click on OK, and you'll see that the hidden lines disappear. What we've done there is we've basically toggled off the display of hidden lines for those particular components. Now, in the browser under Drive System 1, we're going to double click on the side component view to set it to be active. So what we're going to do is look at Drive System 1 here. There it is there. And we're looking down, and we want to look at the drive system, and we're going to double click on the side one here to make it active like that. Can you see it highlights like so? It's that one there. And we're going to create an associative hide condition between the components. So I'm just going to pan up a little bit so we can see what we're doing, and then click on the structure tab in the ribbon like so, and we want to create a hide situation. There it is there. Click on create like so, and it asks you to select the foreground objects. So we're going to keep clicking on the geometry and basically find the following illustration. So what we're going to do is go through here like this, keep clicking on the geometry, and you'll find, you see it going through all different things like that. You can go through and select all different objects. And when you get to a certain point, you'll see a particular piece highlighted like that. There's the foreground object that we want, okay? And what will happen is we're then on drive axle bracket 1. If I press enter now, you'll see that gets selected. And can you see I've got loads of information going on in there now. And I've created a hide situation on those particular objects. So what I want to do there is I want to make sure that I rename that. So I might want to change that to something like shaft end drive. I don't just want to call it hide. So I'm going to rename that as shaft end drive, like so, and press enter. That just gives it a proper name. And the hide situation, when we click on OK, will appear in the mechanical browser. Now, what I want to do here is just look at some elements. Now, if you look, can you see at level 2, I've got the holes and things here. I've also got this line going across here. If I click, you'll see that I can see there's the bracket and bearing. There's the free objects. If I work my way across, can you see I've got each one of those is in a hide situation. I've got the end drive, sprockets, and I've got free objects. Now, those free objects there, I don't want. So I'm going to right click. And what I can do there is I can remove those if I want to at some point. Let's just click away from them for the moment, and then go here and click on there, and I can remove those. Okay, when I right click on them, I can't remove them. I have to use remove here in the hide situation dialog box. So let's zoom in a tad now. Let's click in the drawing area, and you'll notice I can't zoom in and out because of that dialog box being open. Here's the trick. I click on OK, and that's there like so. So the hide situation is available to me now, but it's going to be somewhere up here. Now, what I've got to look for is that hide situation. Where is it in the list? Now, if I expand out on the side view, there's my hide situation there, shaft end drive that I named. And as soon as I do it there, right click, I can display the hidden lines, suppress them, highlight them, or zoom to it. So if I zoom to it, zooms me in nice and neatly. There's the shaft end drive, right click. I can suppress it, I can highlight it, and so on. If I suppress it, what that does is it suppresses the hide situation. If I right click on it and click on suppress again, brings it back again. Can you notice the color change there? So if I now right click on that and suppress it, can you see I'm suppressing the hide situation and they're all becoming contour lines again. If I right click again and switch off suppress, they go back to hidden detail in the hide situation. If I right click again and highlight, that highlights all of the elements in the hide situation in the drawing itself. I'll just press enter there to continue, and you can see how those hide situations are extremely useful. And like we talked about in the previous video, what they're allowing you to do is they're allowing you to work with hidden detail that might not be seen normally. But what you're doing is you're making sure that that is behind the image in the foreground, so to speak. Now you'll notice I'm still in the structure tab on the ribbon. I want to close edit structure. And as you can see, that takes me back to the structure tab on the ribbon. And I can go back to the home tab and I can work in any which way that I want to in AutoCAD Mechanical. That hide situation, again, I can minimize that, minimize that, minimize that. And I'm back to where I was at the beginning in the mechanical browser using structure with my associative hide. In this particular chapter, we're going to be looking at mechanical part generators in your AutoCAD mechanical drawings. And we're just going to have a look at inserting a standard part into a new drawing that we've got for you in the library, which is called bush_assembly001.dwg. It's in the library for you. Download it to follow along with this particular video. Now, what we're going to do is just add a standard part. We're going to add like a bush that comes into the top right view, the hatched sectional view. So zoom in on that view first. I'm going to come in here like so, and we're looking at the top of the view here, this part here. Then I'm going to ask you to type something. So make sure your dynamic input is on or use the command line. And I'm actually going to right click and I'm going to go to recent input. And it's this one here, AMDR bush hole 2D. Now I've used that particular command to test that all of this works. So you can see it's in my recent input there on the shortcut menu. All you've got to do though is just start typing AMDR bush. Okay, so hit escape. I'm going to go down to the command line and type AMDR bush like so. And you'll see on the suggestion menu that you've got AMDR bush hole 2D. So when you select that, it now asks you to select a drill bushing with a hole. Now we're going to go for a front view, like so. And there's lots of different drill bushings in there. You've got headed types and headless types. We want a headed type. You can see the headed type. It has that kind of sticky out bit that goes round, and it's got a head on it so that it ties in nicely. So when I click on headed type, like so, you've got various types to various standards. So we want the ISO 4247, that one there. Now we've got to specify an insertion point for that bush in our assembly. Now I'm going to use the midpoint snap on that top face. So just do a shift and a right click and select midpoint on the overrides menu there, on the snap overrides menu. And we're going to use this midpoint snap here. Left click, come vertically down with your polar tracking. When you see the perpendicular snap, left click again. And it'll now ask you for a nominal diameter of that bush going down through that particular part of the assembly. We're going to set that as 8. So make sure your nominal diameter there is 8 and click on Finish. Now you can see the bush coming through, drag it downwards, and as you come down you can see different values appear. You'll see when you get that intersection there that you've got a size 20. Type in the 20, like so. Press enter to confirm, and that'll place that bush through that particular part in the bush assembly drawing. And that's how you can start inserting all of these standard parts. But just before we leave this video, you'll also notice I've got the content tab selected in the ribbon. And you can see there in that particular tab that there are lots and lots of different standard parts in different panels that apply to different areas of your AutoCAD mechanical drawings. You can utilize all of those to place any standard part in any mechanical drawing. We're staying in the bush assembly001.dwg file. And what we're going to do now is have a look at adding some standard notation on a standard inserted part. So we added the bush in the previous video. We're still zoomed into that view. Zoom out now and pan across to the front view here.
And we're going to zoom in on this area here. So we zoom in, and you need to be able to see the intersection of this center line and this center line. We're then going to go to the Content tab on the ribbon, and we need to insert what is called a clevis pin. That's in the fasteners here. If you hit the flyout menu there, there's the clevis pin there, like so. And we're going to insert a clevis pin, as it says, from the content library. So there's our clevis pins. We need a headed type, like so. And if you scroll down, you'll see there's some ISO ones in the list. And we want this one here, ISO 2341 1986A. So we select it. We need a left side view. So we're going to go there like so. And we now go for the insertion point. Utilize your object snap tracking. So hover over the end of this center line. There's the endpoint snap. Hover over the end of this center line. There's the endpoint snap. Remember, hover, don't click. And then as we get to there, there's the intersection point of the two object snap tracking points. Click there. And now it'll ask you for a rotation angle, you'll notice. So you can move around, or you can just press enter to accept the rotation angle of 0. So I've pressed enter there just to accept the 0 rotation angle. The size is going to be 4 millimeters, like so, and then I click on next. Then we need the length, which is going to be 20, and then I click on finish. And it inserts the clevis pin like that. And if I hover over that, you can see it's a standard content library item, clevis pin, etc., etc. So now we want to add some notation to that to tell people it's a clevis pin. So I'm going to go up to the Annotate tab on the ribbon, and I'm going to come into my symbol panel here. And you want a leader note. So you can see there's all different ones recently used. Insert a new symbol there. You don't need to worry about that part of it. Just click away and just click on the A with the leader line, the leader note, like that. And then we're going to select the object to attach it to. So I'm going to come down here and click on Select Object to Attach. And as I come away, it's very much like a multi-leader kind of idea in regular AutoCAD. So if I go Specify Next Point and click, and then it goes Specify Next Point or Symbol, you'll notice. So if I just press Enter now to accept that, you'll see all of this weird and wonderful text appear. And the good thing is where I've pressed Enter, it's accepted that default symbol in the command line on the dynamic input. And the leader note can now be updated. You can go to the library, you can add leader and text. There's all different settings in there that allow you to create many different bits of annotation. Not going to bore you with all the different types of annotation, but if you look at the annotation that you've got in the drawing, it tells you it's a clevis pin, tells you what standard you're using, it's an A type, and it's 4 by 20. So if I now click on Close Editor, I've added the appropriate annotation quickly and easily because it's linked to the clevis pin symbol from the content library. It's clever stuff, makes your life a lot easier in your mechanical drawings. We're starting a new video now, and we're going to have a look at utilizing the content libraries available to you in AutoCAD Mechanical. The new drawing is standard part 001_content.dwg. You can see the name of the file there at the top of the screen. Download it from the library, as usual, to follow along with the video. We're going to zoom in onto this top left corner of this view here. So get the crosshair over it, just roll up on the wheel a few notches like so, until you can see there's the C section of the steel work there, and there's some nuts and bolts. We want to zoom in on this part sectional area here, like so. So you can see the red hatching top and bottom, like so. We're then going to go to the Content tab on the ribbon and click on Content Libraries. Now, as soon as you do this, you'll see there's lots of different content available. Now, I've deliberately left this in a known location. Now, I've done that deliberately so that I can show you where to find this information. Before we do that, though, content libraries are really useful. You can switch the auto hide on, so it just becomes the title bar. Hover over it, it appears like so. You can also go into settings. You can right click and allow docking to the left hand side or the right hand side of the screen if you wish. So all of that is available to you. I'm going to switch the auto hide off, and I'm just going to drag over to this right hand side of the screen like so. I'm then going to pan here so that you can see the hatched area, the parts section there. Now, you'll see that I'm looking at shaft parts, roller bearings, radial. If I scroll up the list, you can see that there's standard content, and I've gone into the DIN content. So as I scroll down, There's DIN, shaft parts, roller bearings, radial. I've selected the DIN 615-2008, and I'm going to select the front view, that one there, like so. Now, as soon as I do that, it's prompting me for the insertion point on the shaft contour. Now, that's going to be this intersection right here, like so. I click there on that intersection. I then want a point on the center line, so I can go for a nearest point anywhere on that center line, left click. Now, as soon as I do this, it's now looking at the geometry and it's going to calculate where that roller bearing is going to go. So I need to make sure that I put in the appropriate values. So inner diameter, make sure that you've got equals, and that's going to be set to 17 in this case. Outer diameter, make sure you've got less than equals, this one here. It does default to unlimited, so be careful. So you want less than or equals there, and that's going to be 44, like so. That's all you need to change. Click on next, click on next. And then you get the two results here. So it's done the calculation, here's your results. Select both of the results by holding down Control and clicking on both. That'll basically change the information in the result panel. Click on Finish. And then as you come away, can you see when you move your mouse, you can drag the sizes and the position? You want your crosshair up here. Can you see? To the left, upwards and above the hatching. Left click to confirm the position. And there's your roller bearing in place using the content libraries available to you in AutoCAD Mechanical. Another very common component in a mechanical drawing is a chain, a belt, a gear wheel, a sprocket, and so on. We're going to investigate that in a bit more detail with the drawing that's on the screen. It's called gear_assembly 001.dwg. You can download it from the library to follow along with the video as usual. Then go to the Content tab in the ribbon, and we're going to go to the Calculation panel here, and click on the flyout here and select Length Calculation from Chains and Belts. Now, it brings up this particular dialog box, and we want a new tangent definition between sprockets and pulleys. We want to make sure that we're using a chain and not a belt. You'll see that you can go and select things from the library for your chain. Don't do that just yet. What we're going to do is define that in a moment. If you've already got a definition here, next to the library button, it means that you'll go straight into selecting the tangents for your chain or belt. In this case, we haven't got anything yet, so we haven't chosen anything yet. So the next step will be to go to the library after we've specified that we're doing a length calculation. So, new tangent definition, chain, length calculation in the dialog box, click on OK. Now what will happen is it will take you to the library to define what chain you want to use. Scrolling down the list on the right, I'm going to select ISO 606 metric, like so. Now there's lots of different part sizes here. I'm just going to go for the top one, ISO 60605B1. So I'm going to select that there, like so. It's a roller chain in this case. I click on OK. And that's in place. Now it'll ask me for the tangents. Now for this, you have to be very, very methodical. First point of tangent, second point of tangent. Watch how I do this. I'm going to go to the center line. Can you see the blue line there? And click. That's my first tangent. Then I go to the center line on this one. It's my second tangent. And you'll see the first part of the polyline. Then first point of tangent here. Second point of tangent here, like so. And then repeat the process here. So you can have a first point tangent there, second point tangent there. So you've now got the three red lines representing the chain going around the gear wheels. Press Enter to confirm that, and that now becomes a polyline. So you'll see now that you're prompted to select the existing polyline. It is now a polyline going around the three gear wheels. Click. And that's done. So now it calculates the number of links in the chain and the distance to the next link. You see that flash up on the command line. If I press the F2 key, there's the information on the command line. Number of links in chain 58, distance to next link, etc. Press the F2 key again just to lose the command line extension there. Now we need to go back to chains and belts on the flyout and select our chain belt links on the flyout. So now we come in, we want chains, not belts, like so. Now it will prompt us to select the polyline. Now remember, we've already selected what type of chain. So all I've got to do is select the polyline and select a starting point on the polyline where I want these links to show. I'm going to go and hover over that part of the polyline. And can you see the endpoint snap just going upwards to the right there? I'm going to left click to confirm it. Now I get the choice of selecting the size of chain. Now bear in mind we've done a length calculation on the ISO 60605B1. So I'm going to select that one. Then I'm going to click on next. Number of links to draw. Now you can draw as many as you like. There's quite a few in this particular length calculation, but I'm going to suggest 10 is a good number. Click on finish, and now it will prompt you for the direction of your links. Can you see the blue arrow? You can either flip that and go in the other direction, or you can accept it. I'm going to click on accept. So I want it coming downwards to the left like so. Now the orientation of the links. Do I want to flip that? Can you see they're side on at the moment? So I select accept, side on, and there's my 10 links like so. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there's the start of the chain. And you can see that it gives me a hide situation now in that particular assembly. I'm just going to OK that. And there's my chain added to my 3 gear wheels in the gear assembly drawing. It's quick and easy, and it does all the calculations for you. Another major benefit of AutoCAD Mechanical. One of the things that you'll often have to do in your AutoCAD Mechanical drawings is insert a shaft into an assembly. So we've got a new drawing for you to do that, and it's called shaft 001_assembly.dwg. You can download it from the library, as usual, to follow along with the video. Once you've got it downloaded and opened, zoom in on the right-hand view, the one with the cross-hatching, the sectional view, and we're going to place a shaft in that center piece here, going all the way across here. So we're now going to go to the Content tab on the ribbon, into the Shaft panel here, and select Shaft Generator. Now, the starting point will be this midpoint snap here on the support part. Now, you'll notice my midpoint snap isn't appearing. Just go down to your object snaps, click on the arrow, make sure that midpoint is on as one of your running object snaps. Click on the arrow again, and then we can select the midpoint snap here. So we click there, and we want the shaft to go across to the right like that. Make sure you're going horizontally to the right and just left click again. That'll bring up your Shaft Generator dialog box. I'm just going to drag that over to the left, and we're going to select cylinder here like so. And the length of that is going to be 5. Can you see it's prompting you for a length at the moment? So the length of that will be 5. Enter. And the diameter of that will be 35. Enter, like so. And can you see that places a shaft in this bit here? We're now going to go back to the shaft generator and again select cylinder here, like so. And now it's prompting us again for the second part. Now, what we're going to do is do an object snap to the intersection here, like so. So we're coming across that middle part there. So if I click there, can you see that's where it's going, across here? And it's asking now for a diameter, and that's going to be 20 in this case. So type in 20 and press enter. So that's taken us across there. We're now looking at this third part of the shaft, and I'm going to select this option here, wrench, like so. It'll bring up the wrench opening dialog, and we're going to scroll down and find the DIN 475 four-sided. So that's that one there. It's a square. And now we want to find a specific wrench DIN 475. Go up the list and you want to find the 18.1. So SW 18.1, like so. And we're going to give it a length of, in this case, 10. And we're going to click on OK. And you'll see that then fills this part here. We're now going to go to the fourth section, which is a thread. Now you'll notice there's lots of different options here. Have a look at all of them and you'll see that thread is there. We've also got profile, we've also got groove and so on, but you want thread. So click on thread, and now we're going to look for the ISO 261 external threads regular thread. So we scroll down the list, keep going till you find ISO 261, and you want external threads regular thread, that one there. And we're going to select in the dialog box an M16. So all the way down the list till you find an M16. Just keep scrolling, keep clicking, and you can see there's plenty of them. So we want M16, that one there, like so. Now, also as well, tick the undercut button here. You want that on as well. But the length in this case will be 22. And there's our undercut switched on, as you can see. We want to change our G2 value here to 6, like so. And then what we do is we click on OK. And can you see that's placed our threaded part of our shaft there? Now, we're staying in the shaft generator, but this time we want to place a side view. So there's our side view, like so. We want a right-hand side view, so select right. You'll see the little red box appear there. Click on OK, and now you can drag this horizontally to the left using your polar tracking. Pick a point along the polar tracking line and click. And there's our view. Click on close, and you've placed your shaft going from here along this center line, and there's the view of it there, the right-hand view looking from this end that way. So as you can see, placing a shaft in an assembly can all be completely automated using the tools in AutoCAD Mechanical. More often than not, you will need to put springs into some of your mechanical drawings. So once again, we've got a drawing for you. It's called shaft 001_spring. You can download it from the library as usual to follow along with the video. Now we're going to zoom in on the top left view, the front view, and we're going to zoom in on this area here. So you can see that there's a circle here, like so. That is our clevis pin. And if I hover over this circle here, you can see there is just a regular circle there as well. Now we're going to put a spring between the clevis pin and this little point here. Now to do that, we're going to go to the Content tab on the ribbon, into the Calculation panel and click on the flyout for springs and select Extension. Now as soon as you do that, you get a Extension Spring dialog. Expand the list extension springs on the left and then expand standards. And we're going to use the Gutkunst catalog, that one there. We're going to go for the front view in the details here. Now it asks for a starting point. Zoom in above the clevis pin and you want this intersection here, like so. Click on it, move vertically down using your polar tracking at 270 degrees and click anywhere on the 270 degrees polar tracking line. Now the reason you're doing that is to define the direction of the spring. Click. As soon as you do that, you get a rather complex looking dialog box. Leave everything as is apart from the length where it says 160. Change that to 65 and enter. That's all you need to do. Click on next. Now we need to select a particular spring from the table. It's this one here, 1.6 times 14.1 times 38.2x, that one there. So it's third one down on the list. Go to the settings button in the dialog box and switch on form, draw form together with spring. You'll see why in a moment, and click on OK. Then we click on finish. Now it asks us for the topical length. Zoom out a little bit and you can see that our spring is starting from the top of our clevis pin. And we're going to go to the top of the smaller circle. Can you see the intersection there and click like so? Then you'll be prompted for an angle of view for drawing. Click the left-hand one and then click on next. Now as soon as you do that, it prompts you to select a rod. We don't have one. Notice the prompt says enter equals continue. Just press enter and you'll see the spring go in. And where we tick that box for the form, you can now place the form that shows you all of the calculations for your spring. So just click, place it in the drawing, and you can see now that you've got a form there like so. And it gives you all the information about the spring, but more importantly down here, you've got a nice spring showing exactly where it should be in your AutoCAD mechanical drawing. We're starting another chapter now in our AutoCAD mechanical course, and we're going to be looking at creating mechanical drawing sheets. So the first thing we need to consider is, after we've done all our design in the model tab, how do we obviously create that information in a layout with a title block? How do we add viewports? How do we add detail views and so on? So we've got a new drawing for you. It's called views_layouts.dwg. And as usual, you can download it from the library to follow along with the video. So we've got our drawing in place in the model tab. So there's some views. There's a nice side sectional view with all the red hatching and so on. Go to the Layout 1 tab, like so. Click on it, and you'll see there's a title block in there with a viewport in place already. Now you'll notice that the layer of that existing viewport, if I click on it and select it, is AM Views in the Layers panel there. Just hit Escape to deselect it. Now, one of the benefits you have, as I've stressed already in this AutoCAD Mechanical course, is certain objects have predefined layers. So go to the View tab on the ribbon, and we're going to select in the Viewports panel here, Viewport. Now, this is different to your regular AutoCAD. So click on Viewport like so. Come into the drawing area and it says Specify First Point. I'm going to place a viewport down here. So I'm going to use this corner here, click, and then I'll hover over this corner here and then drag down so it all lines up nicely to about there, and then left click. You'll notice the viewport comes in on that AM Views layer automatically, which is really, really useful. Now, what we're going to do now is go back into the model space using these settings here. But before we do that, we set our viewport scale from the drop down at 1 to 2.5 there, like so. I'm now going to select midpoint, and it will drop me back into the model space. And it says select the view center. So I've set the scale 1 to 2.5. The view center is going to be the midpoint on this view here. So I want the midpoint snap on this center line. So make sure in your object snaps here that you've got midpoint set like so, and then just switch off the object snap menu. Use the midpoint snap there and click. Takes you straight back into the dialog box. There's our scale. Midpoint is set. We're going to zoom according to the scale. The view is active. Click on OK, and there's our view. How quick and easy is that? That's really useful. Now, what about if we want to add a detail to, say, Layout 2? So I'm going to click on the Layout 2 tab, which is blank. Just do a little bit of zooming and panning to get it central on the screen. I'm now going to go back to Viewport here in the Viewports panel in the View tab on the ribbon. Click on Viewport, come into the Layout 2 area and right-click and select Border. Takes me back into the model space. I'm going to zoom out again, and you'll notice down here there's a view with a border around it, which is on the AM Views layer. So if I pick that existing border like so, there's the target position. I can position it wherever I want on that Layout 2. I'm going to go top left. Now, you'll notice the scale is picked up at 2 to 1 automatically because of that particular view setting. And what I can do now is make that view active and zoom according to scale. So when I click on OK, it's all zoomed in at 2 to 1. If I select that viewport, you'll see the scale is set at 2 to 1. If I hit Escape there just to deselect it and go back to the Model tab, let's just zoom in on this and go up a little bit and hover over this. What is this? Let's click on it, right-click, and go to Properties on the shortcut menu. And if I just bring this in here like so and look at the properties of this, you'll see it is purely a polyline, as you can see on the layer AM Views. So if I come down here, it doesn't give me any information about that 2 to 1. What it's doing there is it's scaling that view automatically based on that size there, which is really clever. So what it does is it creates a viewport at 2 to 1 for me quickly and easily. And it's done that and put it into Layout 2 for me like so. Now, one of the benefits of this is I can select this, I can click on a corner and drag, and it acts just like a regular viewport, or you might have thought. Can you see there it still keeps the original AM Views line? So if I double click inside the viewport now and pan, can you see the AM Views line is there? Double click outside the viewport and it's still there in the model space. So just be aware with that AM Views layer that it does still show in the viewports even when you expand the viewports. But I can click on the viewport, click on the arrow here. I can change the scale at any time. If I made it say 1 to 2.5, you can see it scales accordingly. Click again and go back to 2 to 1, and it goes back to the right size again. Hit escape to deselect. So once you've got that view in place, don't forget, if you do expand the viewport, the AM Views layer is still visible in the viewport in the Layout tab. We've got a new drawing for you now. It's called sheets_model.dwg. And you'll find this particular drawing in the library, as usual, to follow along with the video. What we're going to be looking at is detail views and scale areas. Now, in this particular drawing, we've already got some scale areas set up. Now, you may remember in the last video, we created that view in Layout 2, didn't we? And it automatically scaled to 2 to 1. That's because it was a scale area. And the best thing about these scale areas is they allow you to drop a view into a layout as a viewport, and it's already scaled. You don't need to think about it. And it's the same with the detail views as well. So in our sheetsmodel.dwg file, we're going to look at creating a detail view first. And we do that from the Home tab on the ribbon. And we go into the Detail panel and we select this icon here, Detail View, like so. So we now have to specify the center of the circle, or if I press the down arrow on the keyboard, I can do a rectangle or an object, or it can be a circular detail view. I'm going to stick with circle, center of circle. So I'll just hit escape once, and then I'll go back to detail view like so, and it prompts me for center of circle. We're going to zoom in on this view here. And can you see we've got this nice detail in the middle? And the center of the circle is going to be roughly a point here. I've gone for an intersection there. Click, and I drag the circle outwards to get the detail. Now you'll see there that the circle is quite large because of where I've picked the center point. Just be aware of that, and you can pick the center point anywhere you like and click, like so. Now, the selected scale area for that particular title block is 1 to 5. I'll show you how to check scale areas in a moment. We're going to specify by factor. I'm going to change that value there to 5, and then we're going to go in here, label A 1 to 1. You want to make sure this is set to 1 to 1 like so. So 1:1. It is just text, okay? That's the label contents. There's the detail boundary, the identifier, which will also be A. So the detail view will have A 1 to 1, and the detail boundary on the view here behind the dialog box will be A, like so. We're going to put that view in the current space, and we're going to click on OK. So there's our circle. Zoom out a little bit, drag across horizontally to the right, and we'll go to say there like that. You don't have to worry about the circle touching the title block. That's purely showing the boundary of the detail view. Now, if I zoom in there now, this is at 1 to 5. And it's got the A designator. There's the boundary now. And if I look here, the A is 1 to 1 because it's 5 times bigger because we scaled it up. So you can see there we've got a nice blown up view of that detail A there. Now, I'm going to show you what these scale areas do now. So I'm going to go to the View tab on the ribbon. There's the Scale Areas panel. Click on Scale Monitor. If I come into this area, can you see now, if I hover there, it's 1 to 5. If I hover in this area, it's 1 to 1, remember? That's our detail view. Over here, in this particular scale area, it's 1 to 1. Down here in this scale area, also 1 to 1. There's also that scale area that you recognize from the last video, which is set at 2 to 1. So just press enter there to close the scale monitor, and we'll create a scale area, like this scale area here. Going to zoom in on the shaft here, like so. And I'm going to create a scale area. Click on scale area, and I'm just going to draw a rectangle. Click, drag, click. There you go. There's my scale area. And I want the scale there to be, say, 2 to 1, like so. Text scaling will update, length scaling will update. I can also have an automatic view creation in any particular layout I want. I'm not going to tick it this time, but I will perform a rescaling to make sure that everything works. Click on OK. Now, there is the objects I can rescale if I wish. I'm not going to, but if I wanted to, I could. I'm just going to hit escape there now, like so. Go back to the scale monitor, hover here now, that is now a 2:1 scale area, and press enter to finish. So that's how you create your detail views and your scale areas that you can put into layout and in the model space in AutoCAD Mechanical. We're now going to look at creating annotation views in our AutoCAD Mechanical drawings. So we've got a new drawing for you. It's called annotation_views.dwg. You can download it from the library to follow along with the video. Now, you can see that there are 3 different views in our model tab when you open the drawing. Now, just before we start, we're going to be creating annotation views using structure in AutoCAD Mechanical. So we need to switch our workspace down to the status bar here, select workspace switching, and select our structure workspace. What will happen there is the mechanical browser will kick in as per the structure catalog, which you can close quite happily. We're going to go to the drawing tab here in the mechanical browser, and you can see layout 1 and layout 2. You can activate either by double clicking. Double click on layout 1 to make sure it's active, because layout 1 says roller conveyor 1500 in the title block. Now, we're going to go to the structure tab now, which we get here on the ribbon when we're in the structure workspace. We're going to go to the build panel and select new. And this will allow us to create a new annotation view of a specific object in our assembly. So if you click on the down arrow here, we want roller conveyor 1500, that one there. And you can see the annotation view name is roller conveyor 1500 AV annotation view 1. Placement will be in the layout, and we're going to select layout 1, obviously, because that says roller conveyor 1500 in the title block. Paper size will be an isometric A3, view scale 1:15, it'll calculate that for you. Base point 000, like so. You do not need to click on pick point. Click on OK now, and there's our first view in our layout 1. So go top left and click. Rotation angle 0, press enter to accept. Then there's the next view, so just place that underneath. Doesn't have to be directly underneath, about there. Click again, rotation angle 0, press enter to accept. And then there's the last view, the third view. Just bring that down to about here. Click there, rotation angle 0, enter to accept. Now you'll notice it tries to place another view of the first view. Just press enter now to finish that command. So there's our 3 views in place in our layout 1 tab. Go back to the mechanical browser and click on the plus sign to expand, and there's our 3 views there. Select the first one, and you'll see it highlights in the layout tab. Right click over it in the browser, select create label. And there's our label. Don't worry about the gobbledygook in the pattern bit. Just click on OK, and our label will appear. Now, you might not see it on the screen. Zoom out, and it positions it above the view. There it is there. So select it, and you've got 2 grips. This grip is where it positions on the object. This grip, you can move the name of the view. Click there, place it to the right-hand side, hit escape to deselect. Same again, second view down now. In the browser, in the drawing tab, right click and create label. Puts it above it, click on OK in the view label dialog box. Click on it, click on the grip, bring it roughly to the right, click again, hit escape to deselect. Third view in the drawing tab in the mechanical browser, right click, create label, OK the dialog box, click on grip, and just place it roughly to the right like that and hit escape to deselect. So we've placed our 3 views and the annotation of those views. We've done all of that using the structure workspace. Now, what happens if I want to edit the names of these annotation views? I simply double click on the title, and there's that view label dialog box with all this pattern in here. Now, if you just click in it and use the arrow keys to go all the way to the left. So you've got now the name, the view name, and if you go across to the right using the arrow keys, you've also got the scale. So there's SV scale there. So the scale of each of these will be what's in the brackets in the annotation view label. Now I can easily just remove all the information I don't want and just leave the information that I do want. So what we're going to do is we're going to go here, go to the end where it says scale, and just get rid of everything that we don't need. apart from struct SV scale. If I click on OK now, you'll see now that I've just got that bit there. And you think to yourself, hang on a second, there's brackets there, and I haven't got a scale anymore like I have here. So what have I done there? What have I done wrong? Well, just undo it one step, or two in my case, because I also zoomed in like so. So if I undo this, can you see it's removing the view, and I have to go all the way back to there to get that view name. So just be careful. Don't make a mess of it, because you will have to start again and add the labels again. So I'm going to leave that last label there, zoom in and double click on it. So you can see there, roller conveyor 1500, top view, and in brackets 1 to 15. Let's double click on that again. And you'll see now view name view. That's the top view bit there. And there's the little arrows there. So I don't actually need those brackets. So let's lose everything apart from struct SV scale. But let's lose those brackets this time, like that. And then I'll click on OK. And you'll see that I just get struct SV scale again, like so. So just be careful when you're editing this information, because it can all go very quickly wrong. If I undo a step again, like so, let's undo a few more steps and go back to here, like so, and click on the grip and bring it in here like this and hit escape. You can see that all that information is really important. So you don't want to try and edit it in a text fashion like I've just done. That doesn't work. What you've got to do is make sure that you've got the right information. So when you double click, you look here, you've got the component name, and there's an equals at the beginning. So there's the component name, which is roller conveyor 1500. Then we've got the structural view name, which is top. And then we've got text, which is view. And then in the brackets here, we've also got struct SV scale. So if I click on this button here, what it'll allow me to do is available variables like so. So I can clear that pattern, I can have a default pattern, and so on. So I can edit the pattern if I want to. If I just do that, what it'll do is it'll add struct SV scale to the end. Now I can edit. If I click on OK, there's the 1 to 15. So be really, really careful how you edit when you double click here. You can't just edit like text. That's really important. You've got to go into settings like so. You can change things here. And also you've got to go to this little button here and select what you want in this area here in the pattern as well. So just click on OK there. And there's our labeling for our annotation views in AutoCAD Mechanical. We're now going to have a look at inserting title blocks and borders into our AutoCAD mechanical drawings. Now, as I've specified previously, you'll find that a lot of things are automatic in AutoCAD Mechanical. This includes the title blocks, and they're all set up in your template of your AutoCAD Mechanical. So you can just go and say, I want this particular title block in place in my drawing. So we've got a new drawing for you. It's called titleblocks_borders.dwg. As usual, download it from the library to follow along with the video. Now we're in layout 2 in the drawing, and you can see the two views in the viewports there. Go to your annotate tab on the ribbon and go into the sheet panel and select title border. Now, one of the benefits here with AutoCAD Mechanical is your drawing borders with your title blocks are already preloaded. So we've got an A3, so we'll leave that as A3. That's a metric 297 by 420 millimeter sheet size. Our title block, we've got a choice. We can pick whichever one we want to use. Select COXYZ title block 1, that one there. Make sure the scale is set 1 to 1. Switch off all of the options. You can see what all the options do. You can utilize those to work individually with each title block. Click on OK. And it now prompts us for the page setup manager in layout 2. We're in layout 2, leave that as is and click on close. There's our title block showing up there. Insertion point, type 0, 0 in the dynamic input and press enter. That places our title block. I can now go in and edit the information. So there we go. We've got drawn by date, etc. Click on OK, and all that information then comes in nice and neatly here into our title block. Now, if you zoom out, you'll notice that the title block doesn't quite tally up with the sheet. This sometimes happens depending on the coordinate settings for the title block and obviously the sheet behind it. Right click on the Layout 2 tab, go to Page Setup Manager. There's Layout 2, select Modify, and we're just going to modify the settings for Layout 2, where plot area will change to extent and will center the plot. When you click on OK, you'll see everything centers nice and neatly. Click on Close, job done. Now, you will also notice that the printer limits, the dashed lines, don't actually tally up with the title block in this case. All you've got to do there is basically change the settings of either the PC3 file or the sheet size that you're working with. Now, obviously, I'll leave that up to you entirely. What I wanted to do there was just make sure the title block sat over the sheet. Now, I can go in and edit any of the information in this title block just by double clicking, and it brings up change title block entry. So I can change the drawing file name, I can change the scale. If I go to next, I've got check by, sheet number, etc. I'll OK that, and we can edit all the attributes there of the title block. Just double click on the wheel there to zoom extent, and then go to Layout 1. You'll see we've got a nice title block all set up in there as well. And again, you can double click there and change the attributes in the title block entry. So you can change the file name, the scale, who it's drawn by, and so on. So the date here would now be 02/11/19, and I'm going to say drawn by, I'm not designer 1, I'm actually SCB, which is my initials. Click on OK, and if I zoom in now on the title block, you can see that I can review the changes that I've made to the title block as well. It's that quick and easy in AutoCAD Mechanical because your title blocks are preloaded for each AutoCAD Mechanical project. Just double click on the wheel there to zoom extent, which is actually good CAD practice to get into when you're working in layouts in AutoCAD Mechanical. When you're creating your mechanical drawing sheets in AutoCAD Mechanical, there are times when you want to create simple revision clouds in your drawings. We're going to look at that now in a drawing that you can download from the library. It's called pump001_subassembly.dwg. And what you want to do there is open up the drawing once you've downloaded it from the library, if you haven't done so already. And we're going to zoom in on number 8 here, which is the drive shaft in the pump subassembly. So get in nice and close so that you can see the drive shaft like that. And we're going to assume that we've made some changes to this component in our AutoCAD Mechanical drawing. Now, in the newer versions of AutoCAD Mechanical, the RevCloud command has undergone a few changes. So what we're going to do is we're going to go to the Home tab on the ribbon, into the Draw panel here, and just pin it open, like so. And you'll see there's your Revision Cloud command there. Just select Rectangular for the moment, Rectangular Revision Cloud. Come into the drawing area and it prompts you to specify your first corner point. Now the bit that has changed in the RevCloud command is the arc length. If you right click and go to the shortcut menu and select arc length, like so, you'll see it now asks for an approximate length of arc, rather than a minimum and a maximum length of the arc. And they've refined the RevCloud command basically so that you're only having to put in the one value. So what I'm going to do here, I'm going to put in a value of 25, like so, and press enter. And then I'm going to specify my first corner point, click, and then drag. And you'll notice that my arc length there just automatically updates. And when I click again for my rectangular, in essence, revision cloud, you can see that it's placed that nice and neatly on the drawing. You'll also notice in the layers panel, I'm placing my rev clouds on a separate layer that is in this particular drawing. So be aware of that. Make sure you're using a separate layer for your revision clouds. It doesn't have to be rev clouds. It could be an AutoCAD Mechanical layer that you might be using. So I'm going to remove that now and just get rid of that in the drawing. Let's try that one more time with a different arc length. So if I go here again like so, select rectangular. Right click and specify arc length. Let's make it shorter this time. Let's make it 5 and press enter. And I'm going to pick a corner point, click and drag. And can you see the difference there with the arc length? And it calculates it for me. Can you see it's calculating those arc lengths for me? So I'm going to pick a point about there, like so. And you can see there that the arc lengths are different. But what it does is it works out the arc lengths based on that value that you've put into the arc length part of the RevCloud command. Now this will work with all of the RevClouds. So you've got here polygonal and freehand as well. It'll work with those too. I'm just using the rectangular purely for speed. So I could go into polygonal here or freehand and it would still ask for that arc length. So what we can do now is we can unpin the draw panel. And what we'll do as well is we'll delete the RevCloud, take that off the drawing as well. Just double click on the wheel to zoom extents. Good housekeeping, as you can see there. And then that drawing is ready to go. Now, obviously you'd cover it in RevClouds if it was going out at the latest revision, but you can see how that works. I'm just making sure that the drawing is pristine should you want to come back to that video again and go through the example again. But that's the newer version of the RevCloud command in the newer version of AutoCAD Mechanical. We're starting a new chapter now in our AutoCAD Mechanical course, and we're going to be looking at annotating within parts, subassemblies, and our AutoCAD Mechanical drawings. The first thing we're going to look at is annotating parts, which is fairly quick and easy. You've just got to know the right way to go about it because it's very different to the way that you might work with annotation in regular AutoCAD. So we've got a new drawing for you. It's called annotation_symbols.dwg. Before you start working on this particular video and you've downloaded the file and you're ready to go to the View tab on the ribbon. Make sure in the Palettes panel that you've switched on your mechanical browser, like so. And then you want to go to the Drawing tab in the mechanical browser and make sure you double click on Block here. You can see it's the current view already in the Drawing tab in the mechanical browser. We're then going to zoom in down here on this view, and you can see we've got a dimension here, which is 150 plus or minus 0.4. We're then going to go to the Annotate tab on the ribbon. And we're going to utilize some commands that you would not get in regular AutoCAD. They're on the symbol panel. And if I come in here, I want this one here. I want a datum identifier. And it creates what is called a datum identification symbol on your part and attaches it to an object in the drawing area. So I click on it, come into the drawing area, and I'm going to click on this extension line of this dimension, like so. And then the start point, you want to get right to the end point of that extension line and click. And then as you come across now, can you see all the information starts to appear? So I'm going to come down like this, click once, like so, and then come across this way to the right and click again. And now you can see there's the symbol I can put in. I can put leader and text if I want to. I'm going to use a symbol, leave it at A and click on OK. And there's my datum identifier off of that particular dimension. Now I'm just going to pan upwards slightly to the right. You can see there's some hidden detail here for a hole through this particular element of this particular part. So I'm going to go up here now and I'm going to utilize these here. Now you'll notice when I click on the down arrow for these, there's nothing used and there's nothing in the library at the moment. But if I click on the icon there, can you see it gives me the option now to select an object to attach to. Now the object I'm attaching is going to be a tolerance this time. So I click on the end here like so on the center line. And there's my tolerance, click again and come out this way, and there's the arrow there like so. So if I click one more time and just bring it down and click again and then enter to finish, there's the information, and I can now start adding values to this. So there's geometric symbols, and I can put a value in there of say 0.1, for example. I can add this then to the library, and then when I next click on that down arrow next to the icon, this will appear. Click on OK, and there's my tolerance there of 0.1. And you'll notice if I click on the down arrow, there's nothing in the library, nothing recently used because I didn't add it to the library. I can also insert a new symbol if I want to at a later date. But obviously when you're using these over and over again and adding symbols to your parts with your annotation, try and remember to add them to the library. Then you can reuse them over and over again. So that's how you add symbols and annotation to your parts in your AutoCAD mechanical drawings. Very quick and easy, very, very different to your regular AutoCAD. We're now going to have a look at power dimensioning in AutoCAD Mechanical. As usual, we've got a drawing for you. It's called power_dimensions.dwg. And what we can do there is download that from the library as usual to follow along with the video. Now, you'll see it's a very simple drawing. We've got a gear wheel there with some teeth on it, as you can see, and we've got a sectional view there, AA. We're going to zoom in on the top of the section AA, like so, here first. And just pan it down so that we can see the top and see some of the incremental steps in that sectional view. We're then going to go to the Annotate tab on the ribbon and utilize the Power Dimension icon here in the Dimension panel. So click on Power Dimension and come into the drawing area. Now, Power Dimension allows you to dimension quickly and easily without having to go in and out of the different dimension types. So my first extension line origin, I'm going to use my snaps here, click and click like so, and then drag upwards and click again. And it will automatically place my dimension. But the nice thing is in the Power Dimensioning tab, the contextual tab on the ribbon, I can now add something like a tolerance, like so, puts the tolerances against the dimension, and all I've got to do now is click on Close Editor, and there's my dimension with a tolerance. So what I could do now is do another one here, endpoint to endpoint, take it out this way, and click again. And there's my tolerance again, because tolerance is still switched on. But I'm still in the Power Dimension command. So the trick I've got now is I can right-click and perhaps specify a different type of dimension. I might go for radial, for example. Then gives me the option to pick what I want, whichever type I want, radius, diameter, and so on. I'm going to select radius. Going to go for the circle here, click there, and as I drag it out, it keeps the tolerance in place again because tolerance is switched on, and I click like so. And then it prompts me to select another arc or circle. So you can see how quick and easy power dimensioning is, but the benefit you've got is you've got all the tools on the Power Dimensioning tab on the ribbon as well. It's a contextual tab, and it allows you to add lots of pieces of information to your AutoCAD mechanical drawings. As you can see there, I've added 3 dimensions, 2 of which are linear, 1 of which is radial, but you can see how much different they are to regular AutoCAD, but more importantly, how quick and easy all of that different information can be added to your AutoCAD mechanical drawings. Multiple dimensions in AutoCAD Mechanical are very different to power dimensions. So we've got another new drawing for you to follow. It's called multipledimensions.dwg. As usual, you can download it from the library to follow along with the video. We're going to zoom in on the plan view, the top left view first. And we're going to have a look at placing some multiple dimensions in the drawing itself. So what we're going to do is look along the top of the plan view here. We've got some holes going across and we've got the 2 corners. So we go to multiple dimension and it now asks us, what do we want to do? Do we want parallel dimensions? Do we want ordinate dimensions or shaft symmetric dimensions? We want parallel in this particular case. And we're going to go for a chain of dimensions going across the top of this view. Now, do we want them in both axes? Well, I'm going to go with one axis in this particular case and click on OK. Now, it says select object, so I'm going to select this object, this object, this object here. Make sure you get that center line, this object here, and this object here. And then I press Enter to finish, and it says first extension line origin. That will be there, like so. And as I drag upwards, can you see they all appear? I just click once and all my dimensions are in place like so, quickly and easily, and enter to finish. Now that's one way of doing things in AutoCAD Mechanical with the multiple dimensions. Zoom out now and pan upwards, and we'll have a look at this view here, and just pan and get it in the center of your screen. So we'll do multiple dimension again. And this time we'll stick with parallel, but we'll go for baseline, like so. Now we've got alignment inside out or outside in. I'm going to go for inside out. I'm going to leave it as one axis instead of both axes, and I'm going to click on OK. And again, it asks me to select the objects. So I'm going to select here and then here. And then I want to select this one here, and this one here, like so. Enter to confirm. First extension line origin will be here, like so. And as you can see, as I come out and click, all of those dimensions are placed nice and neatly for me, and then it's enter to finish, like so. So the multiple dimensions are very quick and easy to place in your AutoCAD mechanical drawings. If I just zoom out now, you can see how quick I can dimension up an entire drawing in AutoCAD Mechanical using those multiple dimensions. We're now going to have a look at editing power dimensions in our AutoCAD Mechanical drawings. We've got a new drawing for you. It's called editing_dimensions.dwg. As usual, download it from the library to follow along with the videos. We're going to zoom in on the plan view, the top left view, first of all. Just zoom and pan a little so you can see the dimensions. Now, one of the nice things about power dimensions is you can select one, like this 150 dimension, and the power dimensioning contextual tab will appear on the ribbon. And the nice thing is I can now add my alternate dimension style here in the dim text panel. Click here and it adds the inches to the millimeters, like so. If I now hit escape to deselect, I've not only got the 150 millimeters, but I've got the 5.91 inches showing as well as an alternate dimension. Very, very useful when you're working in different countries with different localized dimension standards. Let's zoom out slightly now and zoom in on this lower side view here. Now you'll notice I've got 90, 61, 15 and 10 there. Select 90, for example, in that view, and you'll see now that I can add a tolerance to it. If I click on tolerance like so, there's the upper and lower values, and there's the method of display. So I can show any type of display. I'm going to go for that one there. And can you see it just moves it up slightly? Hit escape to deselect, and there's my tolerances applied to an edited dimension, a power dimension. Now, all of this functionality applies to all different types of dimensions in AutoCAD Mechanical, such as a diameter dimension here. So if I click there, that is also, as you can see, a power dimension. This time with the fit and the tolerance, you've got the representation and you've got the fit and you've got the symbol and so on. Now, what I can do here is I can switch fit off like so, and it just becomes a standard diameter dimension. If I switch the fit back on again, it adds that to it like so. I can also go to format here. If I click here, I can switch the formatting on, and I can change the formatting in different ways as well in my dimensions. I can edit the dimension text just by clicking on the button, and there's all the information there. So I can edit that dimension text at any time. Close the editor, the information updates as well. Obviously, I didn't make any changes in that particular instance. But you can see how quick and easy, if I just double click now to zoom extents, it is to actually edit dimensions, especially power dimensions, in AutoCAD Mechanical. One of the lovely features of AutoCAD Mechanical is this automated methodology, this workflow that you have where all of your elements are on the right layers and a lot of it is parametric and automated. Now this comes to annotation with things such as hole charts and fits lists as well in your AutoCAD Mechanical drawings. So you can see we've got a new drawing for you. It's called holecharts_fitslists.dwg. Download it from the library so that you can follow along with the video, and you'll see how quick and easy this is, because those holes shown in the drawing are holes. They're not just circles with center marks, and you can specify an origin, you can specify where those holes are, you can specify the coordinates of those holes as well, and your fits list can be just applied quickly and easily and put on the drawing too. So we're going to go to the Annotate tab in the ribbon. Make sure you are in Layout 1. And in the sheet panel here, can you go to hole chart like so? And it'll ask you to specify an origin. Now the origin is going to be the corner of the red outline of the plate there, and click. And then it'll ask for a rotation angle. Just accept 0 there and enter like so. The name of the origin will be, let's say, O1, and enter, like that. And the origin should go in the corner there on here, like so. So if you zoom in, you should see that you've got an origin. Can you see there? On there. So there's our O1. Okay. So if I come out there, the origin is in place and ready to go. It now prompts me to select the holes. So I click and I just drag a window around that entire shape and it finds all the holes for me. Press enter to confirm. And there's our hole chart. All I've got to do now is specify where I want it to go on the drawing. It's that quick and it's that easy from the origin, the O1 there on the corner. The fits list is even quicker and easier. I just click on fits list and I can either update all, which I'll do, and that updates everything. Then I do fits list again and I've got a choice of ordering or new. So if I click on new, there's my fits list. I'll place it underneath like so. And if I zoom in there, you can see diameter 6, H7, there's the tolerances. So there's the dimension and the fits that I need for those particular holes. Quick and easy, very, very simple. You can see how this automation in AutoCAD Mechanical can make you so much more productive. In the same way that we can add title blocks and automated text and power dimensions to our AutoCAD mechanical drawings, we can also add revision lines and revision lists to our drawings as well. We've got a new drawing for you. It's called revision_lists.dwg. As usual, download it, use it to follow along with the video. Now, if you go into the Annotate tab on the ribbon and expand your sheet panel here in that particular tab, hit the pin there and it expands out, you'll see that you've got revisions on and off, add one revision line, update revision line. So what I can do now is I can add a revision line to my drawing. So I'm going to go add one revision line, like so. It says select drawing border or title block, or if I hit return, I can just put it in global space. I'm going to select my title block, like so. And now I can edit the revision attribute. So this is going to be revision number 1, like so. The first line of the revision will be updated chain supplier, like so. And then you might put new chain. Now, I'm obviously not being very descriptive there. It may be that you put more information in. But when I OK that now, there's my revision line. Now, I'm just going to drag upwards a little bit, and I'm going to use this bottom left corner here and click like so. When I zoom in, not only does it give me the date of the revision, the number of the revision, and the lines that I put in, but it also puts the name of the person that put the revision in there. Now, if I want to update that revision line, what I can do is update it like so. Now I've got to select it first though. As you can see, there's the block name. I can update it. I can change it like that. Now that information can be updated at any time. The revision on off selected there is now that the revision system is now deactivated. Now, obviously, if I go add one revision line, I can still do that, but the revisions won't update. Now, what it does is it marks the drawing as well with those revisions. So make sure your revisions are on and your revision system is activated. It's very, very useful. And that revision system allows you to add revisions as you go. And it updates the revisions on the title block as well. So I can come in here and I can come in here and there's my revisions here as well. So if I go next, you can see that there's my revision number there. So I put revision in there, number 1, and I OK it. So we're now at revision 1. And then what I can do is when I put the next line in, I can update that again and so on. So use those revision lines. They're really useful, descriptive, and allow you to work quickly and easily in your AutoCAD mechanical drawings to let people know what the next revision of the drawing is and what revision you are at on your mechanical drawings. We're working in the drawing pump 001 underscore subassembly.dwg. You can download that from the library to follow along with this particular video. And we're looking at dimensions and in particular annotation in this particular case. So we're not dimensioning, but we're looking at things like text on our AutoCAD mechanical drawings.
Now I'm in the Home tab on the ribbon at the moment, and you'll notice in the Layers panel that I'm actually on the default layer 0. That's our current drafting layer. Now, there is already a dimension layer override function available in AutoCAD and AutoCAD Mechanical. So if I type dim layer like this, you'll see there's the dim layer one there. So if I select dim layer like so, it says find new value for dim layer or use the current layer, which would be layer 0. So I can just use that current one and it will put any dimension annotation on the drawing on layer 0. Now there's also one now available for text layer. So if I type text layer like so and press enter, there's the text layer command. You'll notice at the moment the new value for text layer is the text layer. If you'll pardon the pun, there is a layer called text in the layer drop down. I'll show that to you in a moment. So we're going to use text. That's the current one. Now if I type use current in the little speech marks there, it'll use layer 0. I don't want it to use layer 0. I want it to use the text layer. So I'm just going to type in TXT like that and press enter, which it was already using anyway. So we're going to zoom in now just above the parts list here. So let's zoom in like so that we can see our text a bit better. And then all I'm going to do is create some single line text that says parts list, and I'm going to place it above the parts list here like so. But the most important thing is you'll notice I'm on the Home tab on the ribbon, and in the Layers panel there, the layer is 0. The current drafting layer is 0. If I click on the flyout there, you can see there's our text layer, but it's not the current drafting layer. So now I'm going to go to the Annotation panel on the Home tab on the ribbon, click on the flyout, and select single line text, the regular single line text command. Start point of the text, well, we'll go for that end point down there maybe, or we can just position it just above actually. That'll be a little bit easier. Then it doesn't actually sit on top of the line. So I'm going to pick a point there, and it's saying a height of 2.5. I'm going to change that to 5 and press enter. And a rotation angle there of 0, horizontal, yes please, press enter again. And there's our little flashing cursor. And I'm going to just hold down the caps lock and type parts list. Now, one thing you'll notice is it's red, not white, like the layer 0. So if I press enter once, enter twice, that obviously places our parts list text. Now, here's the interesting thing. If I hover over that and click on it, you'll see that it's on the layer text, because the current text layer using that text layer variable is set to the text layer. If I hit escape, you'll see the current drafting layer is actually layer 0, but the text layer is that text layer in the layer dropdown. And it's really quick and easy to use. Just type text layer, choose the layer you want your text to be on, and it'll always go on that layer when you're working with the text annotation commands in your AutoCAD Mechanical.
We're starting a new chapter now in our AutoCAD Mechanical course, and we're now going to be looking at bills of materials, parts lists, balloons, and annotating our drawings accordingly so that people know which parts go where in an assembly in a mechanical drawing. So the first thing we're going to look at is part references, applying references to specific parts in our drawings. So we've got a new drawing for you. It's called part_references.dwg. You can download that from the library as usual to follow along with the video. And we're going to zoom in on the right hand view here first of all. Now, just before we do that though, zoom in on the parts list down here. And you'll see the parts here like so. I'm just going to zoom and pan a little so that you can see that they're there. There's the parts list added. And you can see that we're up to item number 3, which is the UV filter. We're going to add a new part, edit that part, and then add some balloons as well to show where those parts are on the drawing. Just double click on the wheel to zoom extents again, and then zoom in on the right hand view like so. So there's our right hand view. Now, the first thing we're going to do is we're going to add a part reference to the cover down here at the bottom, this bit here. So we need to go to the Annotate tab on the ribbon, and there's part reference here in the Bill of Materials, the BOM panel. So click on the flyout and select Create. And then we need to select an object. Before we do that, just right click and select Copy. And then what we'll do is we'll copy this particular part reference here. So just hover over it. You'll see it says unnamed. Just click on it. And then we're going to select the object where we want our part reference to go. So that's going to be this line here for the cover. See that line there? Click there and it will give you a new part reference dialog box. We're going to change the reflective housing because that's the description of the unnamed part that we selected. So we're just going to call it cover for now, like so. Click on OK. And what will happen now is if you zoom out and then pan and zoom in on the parts list, there's our part number 4, cover, like so. So just zoom out again, pan back to the view, like so. Now what we can do is go to the Home tab on the ribbon, into our flyout here on Layers, and just pin it open. And you'll see this icon here, which is Part Reference Layer on or off. Click it, and you'll see the part references now are available and visible in the drawing itself. So just unpin that so it goes back into the ribbon. And now you'll see that we've got a part reference down at the bottom here. I can double click on that now and I can change that to say vent cover. Like so. Click on OK. If I zoom out now and zoom in on the parts list, you'll see that it now says vent cover. I've updated the parts list as well as the description in the dialog box. So let's look now at placing some balloons on these references. Now the references are already numbered in the parts list. So I can now go back to my Annotate tab on the ribbon. There's the balloon panel. Just click on balloons. There's already a style in place, so you don't need to worry about a balloon style. And all you do now is pick the part references. So if I zoom in on this top one, there's the part reference. I click on it. I take the bubble out as far as I want it to go. So I might click there and then go horizontally across. Make sure you've got your polar tracking on so that you get horizontal lines. Mine isn't on at the moment. So now if I do that, I get a nice horizontal line and enter to finish. And there's part number 2. And I can just do this to each one. Select a part reference. I could perhaps do that one horizontally. Click there, enter to finish. There's part number 3. There's my part number 4. So I can go across, click there, enter to finish. And last but not least, there's my part number there. And I might just come out horizontally there. And there's part number 1. Enter to finish. And as you can see, the references are now all set up in the drawing and relate to the parts list down here, bottom right. And that's how you add part references to your AutoCAD mechanical drawings. You can add a bill of materials to any AutoCAD mechanical drawing that has the part references applied to it. So we've got a new drawing for you. It's called bill of materials _ parts.dwg. As usual, download it from the library to follow along with the video. Now, this particular assembly in the drawing has had all of its parts references applied. So if I go to the Annotate tab in the ribbon and now go up to the BOM panel and select BOM here, it'll open up a command that says specify bill of materials to create or set current. Now, if I press the down arrow on my keyboard, you'll see that I can select main or use the question mark option to find a bill of materials that's already in the drawing. I'm just going to go for main, like so, and this basically lists all of the parts references into a bill of materials. So they're all here. It's a very large dialog box. It fills up the screen, and you've got items, quantities, descriptions, standards, names of those particular parts. You can add materials, you can add measurements, and if I slide across, there's even more information such as units as well, each, so 1 each, 2 each, and so on. Now, there are a raft of commands at the top here, lots of bits of information. I'm going to show you just a couple that relate to the part references that are already applied. So this is our bill of materials. What I can do now is I can convert this bill of materials to a parts list. So there's my parts list there. So if I click on parts list, it goes into the parts list that relates to the standards for this drawing. So if I click on OK there now, there's my parts list. So I'm going to place this over here on the right hand side and click, and I'll just OK that now and close the BOM. And there's my parts list all listed. Now I can rotate that if I want to. Obviously it's on its side at the moment. I can select that and I can easily just right click, rotate here like so, specify a base point. I'll go say there, click there, and I've just rotated it to the vertical. But there's all my parts and my part numbers, descriptions, etc. Now the benefit I have as well there is if I just do a little bit of zooming and panning to show everything and go back to the bill of materials again. So BOM panel in the annotate tab, click on BOM there. And all I've got to do is press enter to accept that main again like so, and it brings up the BOM dialog box. Notice here as well, I can add balloons based on the current bill of materials. Now the lovely thing about this is they all relate to the parts in the parts list. So if I select, say, this particular frame, take my balloon out, click there, make sure you've got your polar tracking on so you get that nice horizontal line, click there like so, enter to finish, and just enter again to finish. It will take me back to the BOM dialog box and I'll click on OK. If I zoom in on that, that frame is number 8. And you can see the dashed line. That's all part of the standards for this particular drawing. So if I now pan across here and look up number 8, you can see there it's got 1, but it hasn't got a description or anything in place. So number 8 is there. So if I now go to the bill of materials and open it up again and press enter to accept main, notice there's no description. So if I go in there and put frame into there like so, click on apply, click on OK, you can now see number 8 has frame there, and obviously that relates to the number 8 here in the balloon as well. So you can see that everything ties together when you utilize these part references, especially when you're generating a bill of materials in your mechanical drawings. You can also create a bill of materials using structure in AutoCAD Mechanical. Now we've got a new drawing for that. It's called bill of materials _ structure.dwg, and again you can download it from the library to follow along with the video. What we need to do is make sure that we go to our workspace switching down here on the status bar and make sure that we go to structure like so, and that'll tie in our structure settings. So we've got the structure catalog here. We can close that. And you can see now in the mechanical browser, we've got our structure here like so. If I expand out the drive system, you can see we've got lots of different parts in the assembly. And what I can do here is I can select drive system 1, right click, and you'll notice now I can create a create assembly BOM. So if I do that, there's my bill of materials, and you can see there's drive system, shaft drive, bracket, etc. Now I'm looking at the drive system at the moment, which is fine. And that's that particular part in the actual structure here. So you can see in the structure, drive system 1 is selected in the mechanical browser. And then subsequently in the bill of materials, you're looking at the drive system there as well. Now you can see all the information is in there, the descriptions, the standards, the names, like in the previous video. You've also got the ability to create a parts list based on the current bill of materials. So for the drive system now, same workflow, same process, parts list. There's my parts list there. I can insert a title, I can edit it, but this particular parts list name will be the drive system. So this time you will put in an actual name at the top because you're using the structure and selecting a particular part of the assembly or an assembly in this case. So it's parts list, drive system. Click on apply, click on OK. And there's my parts list. Specify the location. So I'll click there like so. There's all the information. Takes me back to the BOM again. And I'm going to click on OK. And now we've got the parts list for our drive system there, like so. So there's all the information. And again, what I can do now is right click on drive system in the mechanical browser in the structure workspace, go back to create assembly BOM. There it is again. There's the drive system. What I can do now is start adding balloons, create balloons based on the current bill of materials like so, and I'll select a part or an assembly. So let's have a look and see what we've got here. We've got lots of different parts, bolts and so on. So what I can do now is just pan across into the drawing area and we'll look at, say, this part here. Select part assembly, click, and just click there and enter. And I'll just enter again to close the command. Takes me back to the bill of materials, remember, so just click on OK to close that. If I zoom in on that balloon, you can see that that is part number 12, and you can see it's the chain there. So if I now come back to my parts list, look over here, Number 12 is the roller chain to the ISO 606 standard. So you can see how quick and easy it is using either regular AutoCAD Mechanical or the structure workspace in AutoCAD Mechanical to develop your bills and materials and also your parts lists and your balloons. We're starting another chapter now in our AutoCAD Mechanical course, and we're going to be looking at using design calculations. And we've got some drawings for you, and the first drawing we're going to look at is a drawing that allows us to calculate the moment of inertia with particular sections and elements in our mechanical drawing. So the drawing is called moment of inertia _calcs.dwg. The usual drill, download it from the library to follow along with the video. Now, we've got some sections in the drawing. You can see there's a section here, here, and here. And there's also a blank area saying rectangular hollow. I'll explain that in a moment. And what we can do is we can generate moment of inertia calculations and place them on our drawings. If we go to the Content tab on the ribbon, and we're going to go into the Calculation panel here, click on the flyout and just expand it out and pin it open as you would normally. And you can see here this icon allows us to calculate moments of inertia. So I click there like so, and I'm going to zoom in on the first section here like this. So I'm going to go in here like this, specify an interior point. So I'm going to go inside the hatched area and click like so, and you'll see the boundary appear, and it creates what is in essence an AutoCAD region. Press enter to confirm that, and you'll be prompted, is that area filled correctly? It is. You can see the whole area is filled, so you select yes. Now you need to specify the direction of the load forces. Now that's going to be here, going down to that endpoint snap, left click. Now, it needs a description for this particular calculation. I'm going to call it Profile 1. Like so. Press enter, and there's the calculation there. And I can just pan a little, just place that above it like so, and click. So there's Profile 1 with all the calculations. I can repeat this now. Go back to moment of inertia here. Specify interior point. I'm going to go 1 and come inside the beam. You might need to zoom in a tad. Click there, click there. That's what you want, that particular boundary. Enter to confirm. Is the area filled correctly? Yes, it is. Thank you very much. Again, we're going to come down to the endpoint snap and left click like so. Enter description. We'll call this Profile 2. Press enter, zoom out a little, place it just above the section and click there. You can see how quick and easy this is, and it's doing all the calculations for you. So, moment of inertia again, and we're going to specify this interior point. And we'll zoom in a bit, this interior point and this interior point, like so. Enter to confirm, is the area filled correctly? Yes, it is. Now this time, we're going to be coming vertically downwards like this on a beam in a different orientation. So we need to just pan up a little bit, make sure that our polar tracking is on. Can you see it ties into that vertical line? Specify vertically downwards, and it'll place it. Description, Profile 3 again, in line with the other ones, and enter to confirm. And there's our Profile 3 there. Just pan and zoom. And again, you'll tidy these up later, getting them all level on the drawing. So there's our 3 profiles, all with moments of inertia calculated. But what about a rectangular hollow section, for example? Well, we've even got a capacity for that. There's predefined profile sections, like so. There's our hollow section there, so select it and click on OK. Now we need to know the length, which is going to be 100. Enter. The Y height is going to be 300. Enter. And the thickness there is going to be 30. That's the thickness of the section. Enter. And there is our calculation. Just place that above the text that says rectangular hollow section. And there you go. 100 by 300 by 30. There's the calculations. Double click on the wheel to zoom extents. And you've now got all of your moment of inertia calculations on your drawing in a few moments. As you saw in the previous video, generating calculations on your mechanical drawings is extremely easy. We did moment of inertia in the previous video. In this video, we're going to be looking at generating our beam deflection calculations. So we've already got the moments of inertia in place in this particular drawing. You can see them in the top left corner, and they replicate what we created in the previous video. We have a new drawing for you. It's called beam deflection _calcs.dwg. And as usual, you know the drill by now. You can download the drawing from the library to follow along with the video. So what we're going to do now is basically create a deflection line based on one of the moments of inertia calculations that we created in the previous video. And we're going to utilize these lines here. So we're just going to use the top line, but you can just use a regular line in AutoCAD Mechanical to represent your beam, because all you need is 2 points and the length of the beam. So if I hover over this, you'll see that it's not any particular part. It's just a line that is a specific length representing your beam. So we go to the Content tab on the ribbon, into the Calculation panel and select Deflection Line here. Come into the drawing area and it says Select Moment of Inertia block. Now these blocks are the moment of inertia calculations. So I'm going to go for Profile 1, the left-hand one, and then it asks for a starting point. So this is our existing beam. Notice we can press enter to select an existing beam, or I can specify an endpoint here, left click, to an endpoint here. And you can see that that's 4,000 long there. So it's basically 4 meters representing my 4 meter beam. Now I can start adding my loads, my supports, and so on. Now we're working to a particular table here, a particular material, and so on. So all of that information can be selected. It does depend on what material you're using, obviously, on how it will deflect under load. So we're going to have a fixed support at the left-hand end. So select it, endpoint snap, click. We're then going to have a movable support, this one here, at the right-hand end, and click, like so. We're then going to have some distributed load, the 3 arrows there, and we're going to go from this point here, left click, the end point, and then shift and right click and select midpoint on the shortcut menu to the midpoint of the beam, like so. And that particular load is going to be 40 newtons per millimeter, like so, and enter to confirm. So there's our load there. We're also going to put in a point load here, so select a point load. And that insertion point is going to be a shift and a right click again and use mid of 2 points there. And we're going to go from this intersection here to the end point here and click. And the line division will be 0.5, half and half, enter. So there's our load. Specify a rotation angle. Can you see you want to be coming downwards? You don't want to be rotating and going off in any which direction. Okay, so you want the load to be coming downwards. So if you move up, the arrow will be pointing down, if you get my drift. Press enter to confirm that. And there's our single force, which is going to be 100. And that's in newtons, obviously, and enter. So there's all our information. We want moments and deflection. We want a moment line and a deflection line. So I click on moments and deflection. And we want direction of main axis 1 and 2 and the result. And we want the resolution of the resultant curve. The table title will be Beam Calcs, because there are beam calculations. So make sure you spell it right, obviously, like me, and click on OK. And what we've got now, enter scale for bending moment line. It'll automatically work out the scale for you. Just accept it by pressing enter. So there's our bending moment line. Deflection, again, it works out a scale. Press enter to accept it. And there's our 2. So the yellow is deflection, the green is bending moment. There's our table, place it on the drawing, job done. It's that quick and it's that easy to work out your beam deflections in AutoCAD Mechanical. You can also generate shaft calculations in your AutoCAD Mechanical drawings. To that end, we have a new drawing for you. It's called shaft _calcs.dwg. And you can download it from the library as usual to follow along with the video. We're going to be using the side view of the shaft, the middle view, not the 2 end views that you can see either side. We're going to go to the Content tab in the ribbon again, and we're going to go to the Calculation panel, click on the flyout to expand it and pin it open. And you'll see that shaft calculation is here. Click on the icon and it will say select contour. Now the good thing is the shaft itself is a part reference in the drawing. So all I've got to do is select the center line of the shaft. There's my contour. Just place it underneath like so and left click. As soon as you do that, you'll see that you've got a shaft calculation dialog box. We're going to add some supports. So there's a fixed support there. So you might want to pan up a little bit now. And our fixed support is going to be on an endpoint. So we're going to do a shift and a right click and select endpoint on the object snaps. And it's that endpoint just there. We're then going to add a movable support. And again, shift and right click. And on the object snap, select midpoint. And it's going to be a midpoint on that face right there. We're then going to add a point load, this one here. And the point load is going to be shift and right click again, midpoint, and it's going to be the midpoint of this face here. Now make sure that you get that vertical rotation angle, okay? You want to put in there that you want 90 degrees, okay? So your rotation angle needs to be 90 degrees. So put in 90 and enter, like so. We then want a resultant load, this tab here, and we're going to put in a force of 2,000 newtons, like that. Click on OK, and the information is there. And if I just move the dialog box, you can see there's our 2,000 newtons point load, movable support there, and there's our fixed support there. So we've got everything we need. So we need moments and deformations now here. So click on moments and deformations. You can obviously edit your material if necessary. Moments and deformations there. And now we've got all of this information in this dialog box here. Just leave it as bend. Don't worry about torsions and stresses. The placement is going to go under the shaft here, like so. Click on OK, and all of that information gets added directly underneath the contour that we set up. We then place the calculations here, just left click and place them on the right hand side, and we're back to our shaft calculation dialog box. Click on Close. So now I can go to my calculations layout here, click on calculations bottom left, and I'm going to double click in this viewport and just do a little bit of zooming and panning to get the view there. There's the shaft, the contour, and all the calculations. Double click outside the viewport, click on the edge of it, and just use the grips to lose those end views either side, like that, and just hit escape there to deselect that viewport. Double click in the right hand viewport and just zoom and pan the calculations table. Double click outside the viewport to deselect, and there's your shaft calculations ready to go in your AutoCAD mechanical drawing. You can generate finite element analysis calculations in AutoCAD Mechanical. We've got a new drawing to do that. It's called FEA_calcs.dwg, and you can download that from the library as usual to follow along with the video. It's a simple pedal outline with a hole through it for a shaft for the pedal to obviously pivot on. Go to the Content tab on the ribbon and into the Calculation panel and click on FEA. When you come into the drawing area, it asks for an interior point. So click inside the pedal boundary, like so. And you'll see there that it highlights the boundary of the pedal and brings up the FEA 2D calculation dialog box. Before we go any further, just click on Config and change your scale factor for symbols to 0.1 and click on OK. That means that you'll be able to see the loads and the supports a bit more easily. Now, what we're also going to do is change the material. We're going to go to Table. And in the table, we select ANSI material, and in the dialog box, just scroll down a little bit, and you want steel SAE 1025. So we'll select that and we'll OK it. Make sure that you give it a thickness. A 0 thickness won't work. We want that to be 7, in this case, 7 millimeters. So let's start adding our supports now. I'm going to go movable support here, and I'm going to zoom in on the circle itself and click here like so. Go around the shape, click again, and click inside the circle, and you'll see that there's our load there like so. Then I'm going to add another one of these movable supports. I'm going to go movable support again, and I'm going to go from this point to this point and move outside and click to place the load. So you can see that load sitting there on that face on the pedal. We're also going to add a force loading with the 2 arrows here. Zoom out a little, pan across, and you want it to go from here, this endpoint, to this endpoint. Again, you want it above that horizontal line. Click there, and the value will be 70 newtons per millimeter, like that, and enter. So there's all our loads. We've got our material. We've got our thickness there as well. We're going to change our mesh triangle calculator here to a triangle size of 5. and just press enter there to confirm if you want to. And we'll now start adding the mesh. So I'm going to click on the mesh and it'll add that mesh to the outline of the pedal. Press enter to confirm that. And that's all in place and it takes us back to the dialog box. Now I'm going to start generating my results here. So I click on results like so, and I'm going to go for the von Mises stress there. And what we're going to do, we're going to go for a graphical representation here on the left, this one. Click on OK. And what will happen now is you'll see all the nice pretty colors appear. So just pan up a little bit and select a base point sort of down here somewhere to click. And you'll see that you can slide that along. Keeping the line horizontal, I'll just pan a little bit so you can see. I'm going to place that there and click. There's my table, click, like so. So it's placed all of that information for me in the drawing and done the calculation. Press enter now to return to the dialog. I'm now going to go here to my calculations for stresses. So I'm going to do this as automatic and click on OK. So there's my stresses there. Again, base point, click down here and then place it underneath. Maybe pan up a little bit just to get it a little bit lower and click there like so. There's our table there. Click again. Enter to go back to the dialog box. Last but not least, we're going to click here and generate our displacements. Again, just go with automatic and click on OK. Base point again. Zoom out a little. Maybe click about here and then line it in, and you just need to zoom and pan a little. Again, these don't have to be perfectly accurate, but just using that base point, you might want to zoom out just a little bit more and line it in underneath. And there's our table there, and click like so. Enter now to return to the dialog and click on close. You now have a drawing with all your loadings and all of your different finite element analysis in the drawing as well. Very quick and easy, and that can all be added to layouts very easily utilizing your viewports as well. We're starting another chapter now in AutoCAD Mechanical, and we're going to be looking at leveraging our AutoCAD Mechanical drawing data. So right now we're looking at a new drawing, driveassembly_custom.dwg. You can download that from the library as usual. And we're running in AutoCAD Mechanical. Now we're going to change our workspace. We're going to go down to workspace switching and go to the structure workspace. So we're working with the mechanical browser, and you'll notice this time there's some information in the structure catalog. So all of this information is available there, and you can see here, if I go to current drawing, I can look at all the information in the structure catalog there. I can close the structure catalog. I can look in here and I've got all the information in the mechanical browser. So you can see that I've got all these different parts available. So I can go for a top view, highlight it like that, side view. There's the frame, there's the drive motor, there's the shaft drive and so on. So all of these have parts and part references and so on in AutoCAD Mechanical. But here's the thing. What happens if someone I'm working with is only running the regular AutoCAD? Well, all of these parts will become what they call proxy entity parts. And it can cause a little bit of an issue in AutoCAD itself, just regular AutoCAD, because they're proxy entities and they become difficult to handle in a regular AutoCAD drawing. So here's the trick. You do a save as, and you save it out as a regular AutoCAD drawing. That removes the proxy entities that are in, obviously, AutoCAD Mechanical. So I'm going to go up here and do a save as on the quick access toolbar. Now you can see I've already created a drawing there called Custom ACAD, and it looks remarkably similar in the preview. So that's what we're going to do. We're going to go down here. We're going to call it Drive Assembly Custom ACAD. Okay. The file itself is in the library and you can download it, and it will be saved out as just a regular AutoCAD 2013 DWG. Like so. So it's Drive Assembly Custom ACAD this time, AutoCAD. So we'll click on Save. That saves it out. Do I want to replace it? Well, I've already got one there, so I'll say yes. You won't have one, but it will save it to your folder. So you're saving that out now as an ACAD file, like so. And then you just obviously hit the Save icon here, and that'll just give you the file name at the top of the screen, which is now Drive Assembly Custom ACAD. Now, in AutoCAD Mechanical, if I hover over one of these entities, let's say one of the gear wheels, it'll tell me it's a content library item. So it's a standard part, it's a sprocket, and it's got the size there as well. Now, in AutoCAD, that would just show as a proxy entity part. And that's what we're going to look at in the next video, is how, now that I've saved this out as an ACAD file, an AutoCAD file, just a regular AutoCAD DWG, we're going to see how that works in regular AutoCAD. I'm now working in regular AutoCAD. In fact, it's AutoCAD 2020, the latest version of AutoCAD. And what I'm going to do now is I'm going to open up that custom ACAD file that we created in AutoCAD Mechanical. So I'm going to go up to Open on the Quick Access toolbar, and there it is there. There's the Drive Assembly Custom ACAD drawing. Now, we save that out as a regular AutoCAD DWG file. It was an AutoCAD 2013 DWG. So when I open that file up, you'll see obviously I don't have things like the mechanical browser or the structure catalog. But let's zoom in on that sprocket there and hover over it. And when I hover over it now, it's just a regular AutoCAD block. It's not a proxy entity from AutoCAD Mechanical. So saving it out as that regular AutoCAD DWG file also removes the proxy entity data. So I'm just going to double click there on the wheel and zoom extents again so that we get it back to the view where we were originally. Now, here's the trick. If I go to Open again and open up Drive Assembly Custom, the one that we created the ACAD drawing from, if I open that one up, the drawing is similar. Okay, we're in one of the layout tabs. Let's go to the Model tab. You can see it looks the same. Now, if I zoom in on that sprocket again now and hover over it, it's an ACAD proxy entity. It's not a block reference. And that's where the issues can occur. So what you want to do is if you've got somebody using regular AutoCAD and you're using AutoCAD Mechanical, make sure that you save out as a regular AutoCAD drawing. It's really important that you do that to avoid these proxy entities that pop up in AutoCAD, regular AutoCAD, on a regular basis. Autodesk Inventor is a 3D mechanical production modeling tool, and it produces different file types to AutoCAD Mechanical. So you have assemblies and parts developed as 3D entities in Autodesk Inventor. What you can do though with AutoCAD Mechanical is utilize an Inventor file and bring in 2D views of that Inventor assembly or part. So we're starting off in AutoCAD Mechanical at the Start screen in the Start tab, and we're going to create a new drawing. So I'm going to go up to the Quick Access toolbar, click on New here, and I'm going to select the ACAD ISO template there, like so, and click on Open. That'll open up a blank mechanical drawing in AutoCAD Mechanical. Now I'm going to jump into Layout 1 here, like so. So I'm in the Layout tab now. Remember that Layout tab. And I'm going to go up to the Layout tab on the ribbon so that I can utilize the ribbon tools to generate my views from an Inventor file. So I go to Create View here and click on Base, and I go from Inventor, like so. Now you'll notice as soon as I do this, I go to the location where my files are stored. Now it's really important that you bring in the parts that come in with this particular Inventor file. So you need to go to the library and download the parts folder. Make sure that that is downloaded and stored in the same location as the Inventor assembly file here. So you got the Inventor file, spacerwedge.iam, but you must make sure that that IAM file is in the same folder as the parts folder, if you get where I'm coming from. So these two particular entities, the IAM file and the parts folder, must be in the same folder for this to work. So what we're going to do is we're going to use the file name spacerwedge.iam. Files of type should be Autodesk Inventor files, IAM, IPT, IPN. When you click on Open now, you'll see that there's your inventor part, and you'll also notice up on the ribbon now in the drawing view creation, I can develop different views. Just stick with all the settings that are there at the moment. So this is our base view of our spacer wedge. So I'm going to put that top left. Now, as soon as I click, I then get various options available to me. And what I'm going to do is I'm going to click on Exit. And as soon as I do that, it allows me now to drag this way to place a projected view to the side. So I click there. I come downwards to project a view this way and click there. If I go diagonally, I can even get an isometric view of my spacer wedge and click there. When you're done, all you've got to do is press enter to finish, and you've now generated 3 AutoCAD mechanical views from an Autodesk Inventor part. Now, that is just really clever stuff. And if you zoom in and look at the detail of these views, you can see how accurate they are as well. They're extremely cool and clever. And what you've got there is a set of views that you can work with and add a title block to and show your finished part in its full entirety from an Inventor part that's been created in Autodesk Inventor. We're starting a new chapter now in our AutoCAD mechanical course, and we're going to be looking at some of the mechanical options that you might use perhaps as a CAD manager. So we've got AutoCAD Mechanical open at the Start tab as if we've just started up AutoCAD Mechanical. What I'm going to do now is start a new drawing. So I'm going to go up to the Quick Access toolbar, click on New, and I'm going to select the ACAD template there like so and click on Open. That'll open up a new blank drawing. I'm then going to right-click and go to Options on the shortcut menu. And you'll notice that I'm in the AM Standards tab there. You've got all these AM tabs at the end. You want AM Standards. And I'm going to click in here and type in Company Standard. So it's a new Company Standard, like so. You can type any name in that standard listing. We're going to apply new settings to layers when the standard is created or changed. And the measurement will be based on ANSI initially. There's lots of different other ones there as well, but we're going to use American National Standards Institute. I'm going to OK that. And I want it to be metric in the drop down as well. So make sure you select metric. So company standard, apply new settings, metric. Now the model scale is always going to be 1 to 10. So we'll use a 1-to-1 scale in the layout, but the model scale will always be 1 to 10. Now, if you've got a default standards template, you can obviously import standard settings there if you want to, but we don't have any, so we're not going to do that. In the standard elements here, you can see we've got everything in place in our company standard. I can go in and edit any part of the standard elements if I want to. So now I'm going to click on Apply. As soon as I do that, AutoCAD Mechanical prompts me to say that a scale has changed. Do I want to start the AutoCAD Mechanical Rescale command to adjust symbol sizes according to the new overall scale? No, I don't want to, but remember, don't tick this box, because if you do tick it, it won't show the dialog again and it won't remind you about rescaling. I always leave those boxes unticked. So I'm going to click on No there. I don't want to start the AM Rescale command. So everything's in place. There's my company standard. I click on OK, like so. So I've got my company standard set up. I now need to save it as a template. So I go up to Save As, and I'm going to go to a new folder first of all. So if I go into exercise files, I've got a new folder here, Mechanical Options CAD Manager. And if I go in there, the folder is empty. Now I can save that as a DWG file, but I don't want to. It needs to be files of type AutoCAD Mechanical Drawing Template. Now, as soon as I do that, it defaults to obviously the standard AutoCAD Mechanical Template folder. So I need to go back again into my C drive, into my AutoCAD Mechanical Essential Training there, into my exercise files, and then into my 12 mechanical options folder there. That's where I'll give the file a name, and that's going to be company, like so, and then I'll put a dash, and then we'll have ANSI, and then metric, like so. So that will be company ANSI metric DWT. So I click on save. I'll get the little prompt here, template options. I'm going to clear all of that. Don't need any of that. And the measurement will be metric. Click on OK, and you'll see that file name change at the top of the screen. Just click on the save icon, and you'll see there that at the top now it says company ANSI metric.dwt. So you can now utilize this template as your default company standard. You can see it in the file tab as well here, company ANSI metric.dwt. And that is how you set up a default template file for your company standards in AutoCAD Mechanical. There may be occasions when you need to bring in a regular AutoCAD drawing into AutoCAD Mechanical and convert the layers and the object properties to AutoCAD Mechanical layers and object properties. So we've got a regular AutoCAD drawing here for you. It's called conveyor_acad.dwg. And as usual, you know the drill by now. Download it from the library to follow along with the video. Once you've got it loaded up, we're going to zoom in on the top left area here, on the end of this conveyor here, like so. Now, all of this is regular AutoCAD information. So if I select this line here, you can see it's on the hidden layer here in the layer panel in the Home tab on the ribbon. Now, I'm just going to hit Escape there to deselect that. I'm now going to go into the Layers panel and click here on the Mechanical Layer Manager. So there's all of our layers that are available to us at the moment. And the current layer is an AutoCAD layer called Visible. Now, if I select Hidden, which was the layer we selected a moment ago, right click and convert to Mechanical Layer, that is now a Mechanical Layer and it's in use. And it's replicated in the layer group. Now, what I can do here is I can start thinking about converting to mechanical layers. But how do I do that when there's no mechanical layers in the Mechanical Layer Manager? Well, they're currently switched off. So if I click here like so, show hide layer definitions, they're all here like so. Now, if I just slide across here, I've got all of the associated objects as well. So you'll notice there, hidden line narrow, if I select that layer there and then go back across, it's the AM3 layer that I should be using for my hidden detail. So what I can do there now is convert this to the AM3 layer. So if I just actually cancel this now, I can click on OK if you want to. All of these need to be on the AM3 layer. Now, as soon as you start converting these objects onto that particular layer, you'll find that you can utilize them for parts and part references and so on as well. Here's a trick though. If I just hit Escape, what I can do here is highlight all of the objects on that layer. So what I can do here is utilize my drop down like so. There's the hidden layer there. So what I can do is I can switch off the other layers that I don't really want to see right now. And it says the current layer will be turned off. That's the visible layer. Turn the current layer off. Now everything there can be selected and be put into the AM3 layer. Now hang on a minute. It's not there. How do I convert it when it's not there? Well, here's a thought. Let's switch those layers back on again, like so, and hit Escape to deselect, and go back to the Layer Manager here. Now, at the moment, these layers aren't in use. Can you see they're grayed out? So if I right-click on AM3 and set it as the current layer, now it's the current layer. It's available. So what I can do now is OK that, and now I should be able to select it here, click on the drop-down here, put it on the AM3 layer, like so. So you've got to make sure that it's the current drafting layer, first of all. So now I go back to the drop-down, and I switch off layer 0. I can switch off center lines, and I can switch off threads and visible. So only things that are there now are hidden and the AM3 layer. So the trick now is to come back into the drawing, select all of these, and obviously they're on differing layers because I put one of the lines onto the AM3 layer, put everything onto AM3, like so, hit Escape to deselect. Now, when I go back, I can select these like so, switch them all back on again, and you'll see now that everything's back where it should be. But if I zoom in now and click on one of these, you'll see it's now on the AM3 layer. So what you've got to do there in your manager, your layer manager here, is make sure that these layers are actually physically on. So there's AM0. If I right click on that, I can delete that layer definition, use it as a selection set, or move it into. If I move it into and select an object here. So if I move it to there and then press enter to confirm, can you see now it's used as an AM layer in AutoCAD Mechanical? And what you'll find is if I OK that and select this now, it's now on layer AM0. So you move it into the drawing and start converting through slowly onto your AutoCAD Mechanical layers. Annotation properties can be configured by standard in AutoCAD Mechanical. So we've got a new drawing for you. It's called configure_annotation.dwg. And we're just going to go through how, as a CAD manager, you would set up these standards for annotation in your AutoCAD Mechanical drawings. So you can download the drawing, obviously from the library, and use it to follow along with the video. And all we're going to do is, with this drawing open, it's in the Layout 1 tab, is right-click and go to Options on the shortcut menu. And we're then going to go to the AM Standards tab. So you'll notice we're using the company XYZ standard, and we've got a measurement of metric with a 1:1 scale. So that's all of our standard settings there. What about in our standard elements here? You'll notice we've got dimensions, for example. Double click on dimension and you can see there's a whole load of settings in there that you set up to configure your annotation within your company standard. So, for example, if we look at chamfer, choose the default representation for chamfer dimensions. If I go down here, I can select lots of different settings. I'll OK that like so. Radius is the same. You can see that I can select different settings for radius representation. Diameters as well. Different diameter representation. All of these can be predefined by each specific standard that you use. So we've got predefined text. There's all the information there, different characters, add, remove, and so on. There's a whole list of different styles there that are used in your standards. Tolerances, again, default method, click on the down arrow, all different methods of displaying tolerances in your AutoCAD Mechanical drawings. Again, I'm not making any changes here. I'm just clicking on cancel each time because I don't want to change anything. What about when a fits list requires updates? Ask first, automatic, or manual. So you've got different settings there as well. I'll click on cancel because I don't want any of these to change. If I look at something like a whole chart, double click there, you can see that we've got a title pattern, a text style, a heading gap, a row gap. This is all annotation that goes onto your AutoCAD Mechanical drawings. Again, things like a drawing sheet. Which drawing sheet are you using? Which default title block are you using? What default revision list are you using? So all of this information annotates on your drawing sheets. As you can see, I could probably do an entire course on configuring annotation in a standard that you might be using in AutoCAD Mechanical. But the whole idea is you create your company standard up here, set your settings for your standard here, and then all of your standard elements, including your annotation, are in this list here. Just as it says, double click to edit the settings that you need to change for your annotation in your AutoCAD Mechanical standards. Other types of annotation that you might configure are your bill of materials, your parts list, and your balloons. We've got a new drawing for you just to go through that. It's called configure_BOM, bill of materials.dwg, and as usual, you can download it from the library to follow along with the video. We're currently in Layout 1, and you can see how all of your dimensions, your balloons, your parts list, and so on are all sitting there quite neatly and tidily in the Layout 1 tab. Now, if you go to the Annotate tab on the ribbon and click on BOM, in the BOM panel, you'll see there is your bill of materials there, like so, and it's all set up with the item numbers, the description, the standard material, etc. Now, there are various ways that you can generate a parts list. There's a parts list here. You can generate it from the bill of materials, and there's your balloons there as well, based on the current bill of materials. But how do you set all of this up as a standard? How do you work with it? Well, I'm going to click on Cancel there, and I'm going to right-click, go to Options, and go to the AM Standards tab, which is already current. You'll notice there's a BOM parts list and balloon option at the bottom of the standard elements in the standard that you're using. If I go to BOM, you'll see there that I'm using ISO 7573 2008E, and there's the available component properties that I can use. So this is all the information that comes off of those part references that I've brought into my AutoCAD mechanical drawings. So there's things like item, quantity, name, etc. I can also look at the parts list, the settings for the parts list, and the balloons like so. So you can see there, expression user 1, quantity, and it's all in here in the list. If I go to component properties, there's the component properties that I can use. So I've got things like description, standard, material, cut length, units, total length. They come from the bill of materials where I've put the information in, which comes from the standards I'm using in the company standard I would be using, in this case company XYZ, in the options dialog box. So I'll OK that for the moment, and I'll OK that again. So basically what this allows me to do now is start adding balloons that actually work with a particular standard. So I can now just go and click on balloons like so, and I can select a part or an assembly. So for example, I'll select that part maybe there, like that. Now there's parts in the drawing. Now you'll find that I can't select these. I need to go into my model to do it. So hit escape a couple of times, go into the model, and there's all your parts there in your model tab. So all you can see is just a structure. You can see them there like so. So how come those balloons are working in the layout 1 tab like so? Well, what I've done there is I've gone to the bill of materials here, and I've generated a parts list from the bill of materials. If I click there, that generates a parts list. I click on OK, and I can place that parts list quite happily in the layout like so. It's already there, so I don't need to do it, but you can see, look, there's exactly the same shape. I'll just hit escape there to cancel the command. It's the same with the balloons as well. If I want to place balloons, I would go to the BOM like so, and then go balloons here, and you'll notice now I can start selecting the parts and adding balloons to them. Now all of these balloons are already placed, so I can't really put another balloon on there because it's already there. But you'll notice that I've got lots of different options. If I right click, I can do a manual balloon like so and select an object, and I can click on it and I can basically accept that one there. There's the part reference and so on and so forth. So I can add manually balloons as well. I'll just cancel that for the moment, but you can see that the quickest way to obviously work with things like your bill of materials, your parts list and your balloons is to make sure that the bill of materials is accurate and current, and then place your parts list and your balloons from the bill of materials that you've already set up in your AM standards, in your options in AutoCAD Mechanical.
One of the great new features that's come along with the 2022 subscription to AutoCAD and AutoCAD Mechanical is the trace functionality. Now, the trace functionality in the 2022 versions is really useful, but you do need to be using the AutoCAD web app or the AutoCAD mobile app. Now, when I say that, what it normally means is that you're logged into your Autodesk account here, like so. Now, if I'm logged into my Autodesk account, that allows me to work with the web and mobile folders or another cloud-based provider. So what I can do up here, you'll notice I can open from web and mobile and save to web and mobile. So what I've done in this case is I've saved the pump001 subassembly.dwg file to the web and mobile folders. That has then allowed me to provide a markup in the trace functionality in the AutoCAD mobile app. Now, I'm not going to bore you by showing you my phone screen or anything like that. Just be aware that what I've done is I've added a trace to this particular drawing in the web and mobile folders using the AutoCAD mobile app. Now, what does that mean for you with the trace functionality? Well, what it means is if a trace has been applied to a drawing in the web and mobile folders, I can check that trace in my AutoCAD Mechanical desktop app. And it's very quick and easy to check. I go to the Collaborate tab here, like so, and then all I've got to do is go to the Traces palette here in the Traces panel. So if I click on Traces palette now, you can see there that there's a title block update revision 1. So that trace has been applied in either the AutoCAD web app or, in my case, the AutoCAD mobile app. So if I select that trace now, there's the trace that I've applied. I might have done this on site, I might have done it while I was on the road using the mobile app or possibly the AutoCAD web app. Now the benefit I've got there is that I can highlight that, I can see what needs to be done, the title block needs to be updated in this particular case, I can apply that update, and then once it's applied I can delete that trace if I need to from the drawing and perhaps save the drawing at the next revision. But what I can also do here is I can change the highlighting. So if I go front or back here, you can see that the trace is still there, but the drawing has been brought forward, it's more prominent. If I click again, you can see the drawing is faded and the trace, the red line on the trace, is obviously more prominent. Once I've finished with that trace, it's a simple click on the green tick, and as you can see, it disappears from the drawing area, but the trace palette is still open. So if I've got traces here in the traces palette, I can obviously select them, and what I can do is I can also check by hovering over them who's created them, the date, the time, etc. So that's my revision 1 title block update. I would make the changes and save this drawing with a different revision and perhaps let the originator of the trace know that I've made those changes. I can then close the traces palette, job done, drawing saved at a different revision based on the updates made in either the AutoCAD mobile app or the AutoCAD web app. One of the really cool new pieces of functionality in the 2022 release of the AutoCAD mechanical software is the count command. The count command allows you to count the regular AutoCAD blocks that you have in your AutoCAD mechanical drawings. Now, one of the things that it might not count in your AutoCAD mechanical drawings is all of the elements that you've brought in from your AutoCAD mechanical libraries. Now, the reason it won't bring those in is they're all tied together in the database in your AutoCAD mechanical drawing. They're not regular AutoCAD blocks. However, I can demonstrate the count command in the pump001 subassembly.dwg file because the title block and these parts of the title block here are just standard AutoCAD blocks. So we've got the standard A3, ISO A3 outline there, and this part here is also a standard part of the title block, and they're just standard AutoCAD blocks. So for example, if I double clicked here, you can see that I can edit the attributes in that part of the title block, and it's called DIN title, you'll notice there. The A3 part of the title block is this bit here, the outline, the boundary. So let's have a look now and see what we can look at with the count command. So you type count like so, comes up on the dynamic input over on the right there, and you can see there's other count commands and system variables available. Just type count though and press enter, and it now prompts you to select target objects. Now your target objects could be specific blocks that you want to select using the pick box. You'll notice on the command line I can list all blocks, which is what I'm going to do. Press enter to confirm that default there on the command line. And as you can see there now, it's telling me I've got one DIN title, as you can see, and one DIN A3 block in the drawing. So the DIN title part of the block is here, like so, and that's got the attributes. So if I just zoom out slightly, DIN title is there. That's that bit there. And then I've also got the DIN A3, which is that bit there. So I've got two blocks. Now what I can do here is I can bring a table in with the numbers of the blocks in the drawing. And I can do that very quickly by clicking here. So I can create a table, and then I select all my blocks. There's only two, so I might as well tick the select all blocks at the top. Click on insert, and there's my table there. When I click there, you can see if I zoom in now, DIN A3, DIN title, and there's one of each in there. Now you'll also notice that in the count column, the numbers are highlighted with a grey background masking. That's because they're fields. So if I bring another, say, DIN title block in, that'll update to 2 when I regenerate or save the drawing. So that list of blocks will update the more blocks you bring in as you count them. It'll automatically count them when you save or regen the drawing, which is quite useful. So what I'll do now, I'll just delete that table. We don't need that anymore. That's just a demonstration of how the table works. I can close the count palette by clicking on the cross, double click on the wheel on the mouse to zoom extents, and we're back to where our drawing was at the beginning of the video. Another really cool new feature in the 2022 release of AutoCAD and all of the other AutoCAD toolsets like AutoCAD Mechanical is the floating file tab. Now this is really useful if you've got a dual screen environment or even a triple screen environment. Some of the more modern graphics cards allow you to have up to 5 monitors connected to your graphics card. So you can span across these different monitors using this floating file tab in the 2022 version of the software. So I've got the pump001 subassembly.dwg file open, and what I can do now is I can click on the file tab and just drag it around. So as I move it away, can you see there that it now highlights the start tab over here? That's still connected up here under the ribbon, but I can move this drawing around, and this drawing can now be dragged over to a different monitor in a different environment where perhaps I might be using a dual monitor or triple monitor environment. And what I can also do is if I want to place it back, I just hover. As you can see there, can you see the blue tab appearing there? And it kind of highlights in a blue color. When I release the mouse button after dragging it, it just drops it straight back into the file tabs at the top of the screen there under the ribbon. It's a really nice new feature if you need to have multiple drawings open in AutoCAD Mechanical. And if you're using dual monitors, I can have one drawing open on one monitor, another drawing open on another monitor, and it means that I can kind of visualize what's going on in both drawings a little bit more easily. I could have 5 monitors and have 5 drawings open if I wanted to, but that's entirely up to you and on how many monitors you want to have. But I don't have the screen real estate when I'm recording the video for you here. I've only got the one monitor that I can record on. So I can't really show you a dual monitor environment. It would be nice, but I can't. And as you can see, it's quick and easy. You just simply click and drag on the file tab and it brings the drawing out like so. Click and drag back, little blue tab appears, pops it back into the file tab arrangement underneath the ribbon in AutoCAD Mechanical. When you're working in your 2022 version of AutoCAD Mechanical, you'll notice there's a new icon on the quick access toolbar. It's called Share, and it opens up the Share Drawing command, as you can see, and you can share a link to the current version of your drawing, including any external references, your XREF files. Now this is also available on the Collaborate tab on the ribbon, and there's Share Drawing there as well. You can recognize it by the little icon that kind of represents a paper plane kind of idea there. Now, when I share my drawing, if I click on it like so, what will happen is it opens up the Share a Link to this drawing dialog box. And what I can do now is I can share a copy of the current version of my drawing, as it says there, including any XREFs, and the link expires in 7 days. So I can set it to either be a view-only drawing, as you can see is the default there, view only. Anybody with that link can view the drawing but can't modify or save a copy. So basically I can put that link, I can copy the link, there it is there, into something like an email, send it to somebody, they click on the link and it will open up a view-only version of the pump001 subassembly drawing. If I want somebody to edit and save a copy, what I can do there is I can click on this link here, like so, and that'll provide a different link, and again I can copy the link and put it into an email if I want to. The benefit you have is this will open it up in the AutoCAD web app, which means that obviously you can just log in using web.autocad.com and your Autodesk account, and you can go and edit and save a copy of this drawing like so. And it's a very quick and easy process, but the benefit you've got is you can set the permissions, view only, or edit and save, and you just copy the link and send somebody the link. Such is the benefit of the modern internet. I can quickly say, have a look at this drawing, is it going in the right direction? Or, here's the drawing, you can make the edits, save a copy, send it back to me, upload it to the cloud-based server, or whatever. So you can share links to your drawings now very quickly and easily in the 2022 version of the AutoCAD Mechanical software. We've come to the end of our AutoCAD Mechanical course, and I really do hope you've enjoyed the course and learnt from it.
The whole idea of this AutoCAD mechanical course is to make you an efficient AutoCAD mechanical user so that you can utilize that knowledge in the workplace or even at home if you're a hobbyist and you're learning how to use AutoCAD mechanical for the first time. The knowledge you gain from this particular course takes you into the mechanical drawing arena with AutoCAD. And what it does is it teaches you a lot of mechanical philosophies, terminologies, and methodologies that you would not normally gain if you were using just a regular version of AutoCAD. As I said earlier, I really do hope you've enjoyed the course, and please don't hesitate to move forward and learn other things about AutoCAD in the library.